Which one are you buying? Good morning, everyone. Welcome back. We're going to start in a few moments. Yeah, there we go. Oh, what's that?
No, you start. I'll talk about wins. I can do that.
Oh, okay. Okay, welcome back, everyone. Thanks for coming to day two. A couple of quick notes. We have a QR code for parking that's at the registration desk. So if you are in the parking garage and don't have the QR code in an email, you can take a photo of it at the registration desk. And the Wi-Fi credentials that you received yesterday should still work. We've heard a few people have trouble with them, but they did work for me. If you try yesterday's Wi-Fi credentials and it doesn't work for you, see just new at the back, and we'll get it sorted out. And I will turn it over to John to talk about the lightning talks.
So this afternoon at 3:15, we're going to have a 30-minute session of kind of quick work in progress or lightning talks to close us out. If you'd like to give one, as Ed mentioned yesterday, this is not really something to do a 30-minute presentation with 20 slides. You got 5 minutes, probably don't even bother doing a slide. There's a whiteboard on the back that I've written lightning talks on. You can sign up on there, and we'll go until we run out of 30 minutes. So sign up early, because if you're at the bottom of the list and we run out of time, then see you next year. But I think with that, we're going to turn it over to Colin. You good to go? All right, go for it.
Thank you. Can everybody hear me okay? Yeah, so, yeah, okay, so, yeah, it's been a long time not doing any, like, a public switch. I think last time I did a public switch is, like, I think it's 9 years ago, before I joined Microsoft. So after joining Microsoft, it's all internal meeting, internal texture, something like that. So, yeah, glad to be here. This is my like very first in BSD conference. yeah, this is my very first time, and thank you for this opportunity to present this one. So here's the agenda. I will talk about like a recent contribution that FreeBSD Foundation with Microsoft, and also about like what kind of like Azure ecosystem engagement. And second, and then I will mention those contributors, and so you have a better idea like who in Microsoft is working on FreeBSD. And then third, I will talk about that's the main topic today. Is about the project we are trying to do. It's a prototype right now to let you to do the CI pipeline with your own setup, not without using like Jenkins CI or some other things. And it's all around like Azure ecosystem. So yeah, I add these slides yesterday because I think it's very good to explain terminologies beforehand, because like like internal meeting, we always do something like ADO, and then I think in a public conference people won't have knowledge like what ADO is. So when I try to always say Azure DevOps today, but if I accidentally mention ADO, that means Azure DevOps. So it's so just a quick survey here. So any one of you ever use Azure DevOps? I see few hands, very few hands. Yeah, yeah. So normally I don't have to ask this question, of course, inside Microsoft. So for your better context, Azure DevOps is a platform to provide like a one-stop website web services, provide you for like a project management, co-hosting like GitHub, and also like a CI, like a Jenkins CI or just Travis CI, those kind of thing, and also including auto deployment. It includes like every service you need for building your applications. And then it was called Visual Studio Team Service before, so also called VSTS, if that ring the bell. And then when I mention build pipeline, that means continuous integration. So it's just like a normal integration, but in there we call it build type pipeline. So if I essentially mention this again, it's it's a CI basically, and release pipeline. That's how we call continuous delivery inside ADO concept. Okay, yeah, I just say ADO again. Okay, so here's my introduction. So I'm Colin. I'm from Microsoft Azure Linux Community Engineering. I know it's weird to see a term Linux like happening here, but this is what it is, because if any one of you is using Azure, you know like when you are using FreeBSD on Azure, you had to kind of assign it as a Linux, because we use Linux this term to be like any like a Unix-like system, because a lot of infrastructure is actually shared inside Azure ecosystem. Yeah, there's a space to improve, so that's why I'm here to provide an update like how we improved recently, and then how we can do better. So thankful Liwen. So Liwen came to me and provided this opportunity. Says, oh, okay, we have something. We are really doing activity. So it started with like a pause. Like I paused on my Facebook about like, since I joined community engineering starting this year. So our target is like try to reverse it. We are not just, okay, we're doing a product and then let the open source community just come to say doing their work to just try to adapt the product like just like other clouds. So we want to do it reversely. We want to stand into a perspective of a community. So we want to thinking if we are like an open source community contributor, what we do, and then just by the chance, if there's really somewhere we can leverage Microsoft resources, then we do over there. So yes, since again, Liwen mentioned this one. He saw the pause, so he came to me. Oh, we have an opportunity to doing this one because we are currently actively working on Azure stuff. with CI. So yeah, that's kind of like my strengths, because in the past, starting Microsoft, I started like my first 5 years in Microsoft in Bing team, so which is like a Bing core thing is about like index serving pipeline in Bing. So it's like from the index file on the machine, and then try to retrieve those index file and then just present to your search, like your default search result. And then when I was there, I was doing a lot of like test integration, CI integration, try to improve the inner loop, and like even optimize the compiler settings to be able to make our production more efficient, like make a runtime run faster. So we're doing a lot of like CI integration over there, with a lot of tasks over there, and then those CI pipeline, it take a week to finish the running. So like when you start a CI, and even without like a manual interfere, it still required a week to finish, because there's a lot of tests inside there to be able to run. Some tests last like a few hours. Some tests last like 7 days to be able to finish running. So yeah, so when I see this topic, oh, this is a very good thing that I can contribute to FreeBSD community. And also, there's multiple people inside Microsoft is also contributing to FreeBSD ecosystem. So Sandeep is the PM from Azure Community Gallery. So we had a talk. We met at Open Source Summit. Yet I met my colleague in Open Source Summit. So we figure out, oh, we are actually have a lot of things we can do for FreeBSD community. So yeah, we think that's something we do. So he's working on from Azure Community Gallery perspective. So if anything in the future you encounter anything in Community Gallery, you can contact Sandeep, or you can contact me. I can reach out Sandeep about like Community Gallery opportunities. And so that from Azure LSG team. Yeah, again, it's a different Linux thing inside Microsoft, but things like right now, Linux system team, they are usually working on Unix-like system, so we do have some work over there. And also Wei Hu from Microsoft Shanghai, he's actively working on, I think probably in this room there's already few people working with Wei Hu before. So he's working on more hardware stuff on FreeBSD. Like some Hyper-V stuff. Okay, so I do a lot of test automation when I do with ADO, of course, because inside Microsoft we have to use that, and it's really a convenient system. So I will talk about that later. So before come to this meeting, I was trying to find my connection to FreeBSD because it was like kind of like a decade ago. I started using FreeBSD long time ago. So here's what I found. This is my first visa later. So this is my photo on my first visa. So actually, I'm wearing FreeBSD logo shirts on that. I didn't bring that passport today, but this is the connection I found. But yesterday, after the last talk about BSD, I found another connection. Is I'm wearing a green Converse. I think I'm probably the only one wearing a green Converse in this room. Yes. So yeah, good. Find another connection. So yeah, I was going to put this on the slide, but that's too much. Yeah. So so I started using FreeBSD in my first year in the university. I was in Taiwan, so I studied in National Jeonju University. I studied in mathematical sciences. In that department, all of our server is FreeBSD server. So I spend a lot of time working on that because I'm always connecting to FreeBSD server. So this is probably the first Unix system I learned how to use. I know it's probably not the first time I use Unix-like system, but I remember like in my 6th grade when I was in elementary school, I received a live CD from Red Hat. So it's kind of like a Chinese translated for the book. So introducing Linux, and they use Red Hat. So they provide a CD with the Red Hat icon on it, and I I was always using Windows, but so I just tried to turn it on. I said, oh, here's another Windows without games. and then I just turn it off. So I don't really actually get on the get on this system. So FreeBSD is really like when I joined university and starting because we have a lot of computation to do. Like we need to use there's a it's called Octave. Is another because we are in mathematical science. We have a lot of computation to do, and we were using the Unix version of MATLAB. I'm not sure whether you know that is a like a more math software to be able to calculate other things. So we always need a server. So we accessing to some server to do something over there. Yeah, and then also we write a lot of Python program. Yeah, yeah, that's my connection. And then there's a lot more like ongoing collaboration from Microsoft. So if you are working on FreeBSD, you might heard one of them. So like they were publishing the FreeBSD official images on Azure Marketplace. So right now on Azure, if you want to use FreeBSD, it's just simply as like you just go to Marketplace, and then you will find FreeBSD image, like official image, on the FreeBSD Foundation as a publisher. So they do publish FreeBSD official images, so you can actually one click to create a FreeBSD virtual machine over there on Azure. And then there's a lot of different effort, like Sowerby was working on hypercode feature and ARM64 support on Azure. I think this is like the recent topic, like Azure is introducing ARM64 machines on there, so you can have that kind of machine type if your program is running on ARM. So the FreeBSD is also supporting there, and then there's like Azure V6 VM SKU support, and then FreeBSD Hyper-V support. And then yesterday, foundation update, they say like there's something going on .NET. That's it. And then about today is about the community edition of ADO's pipeline integration. That will be today's topic. Okay. So here's the project. It's FreeBSD side pipeline on Azure. So I will introduce what I mean and why do we need this. Okay, so the project goal here is we try to automate the steps that you need to build an OS image. So today's topic we will always focus on is not about like other services in FreeBSD. It will focus on the FreeBSD OS image, especially on Azure one. So we want to automate the procedure to build and run the test, and then try to have some place to be able to this or your like OS image build snapshot over there, like one single place, so you can see all of the version you are building over there. And then also the second thing would be most important topic in today's talk is it's not for like introducing another CI here for everybody to go to different places to see your build, or just another opportunity. It's actually about to provide a template that everybody can use. So if your company is using FreeBSD right now, or you use it earlier even before Office image release, you will have to do your custom image. So this talk today, we try to set out a standard that you can use because it will be migratable. It will be, I will introduce a little bit later, but it will be just a single file. You just need to migrate into your repository, and then you will be able to set it up in your Azure subscription, and then you will be able to run your OS image CI pipeline over there without any like extra effort. You don't have to set up a standalone CI server. You don't have to like set up those things. All the things on Azure Cloud. So before going next, because yeah, Microsoft Azure paid me to be here, so I feel like this slide can be improved. So here we go. So I will just keep mentioning. I will highlight all the Azure word here. So yeah, so this talk will be heavily depend on Azure. So but it can be any cloud you like after you publish your image. I mean, the image, OS image variant could be in different cloud, but just our main focus is like to show a streamlined prototype running on Azure. So like how you can achieve all those kind of things on Azure ecosystem. So why in this stage FreeBSD would need this? The first is, so recently we do have a mirror like a FreeBSD SRC on GitHub right now. So I asked Lewin like what's our initiative in the beginning. We want to have a GitHub here. So actually the GitHub right now, you can create pull requests over there, but it doesn't merge. But it's still a good way to receive patch. So because there's a multiple way we can receive patch for OS image, but and so for FreeBSD SRC. But like this is a more modern way right now in the community, especially if you want to have a more new blogs into this community, we need to like adapt the better way, like not the better way, the more modern way. So a lot of people can, because they probably use GitHub a lot in different projects. So if there's a way that they can work on FreeBSD the same way, that would be better. So it's a good way to obtain patches, and also it's a good way to do a review. So Azure DevOps integration can happen on GitHub. We will look into detail on that in later slides, and then it simplify integration with Azure Cloud ecosystem, which is like if you need to set up a lot of things on Azure Cloud, like you need to start an Azure VM in your pipeline. It doesn't require you to do a lot of like a credential work, a lot of things, because on ADO is supported natively. So it's just like you just need to tell me like which subscription you want to go, and then it will automate in the task, like an Azure related task. It will automatically authenticate your task to be able to access your resources on the Azure cloud. And then also one more thing is Azure actually supports all FreeBSD tier 1 architectures, but which is actually just MD64 or ARM64 right now. But it supports more imaging in the future. So right now, for OS imaging testing, like if your OS image is going to be on these two architectures, you can test it all on Azure Cloud, just without setting a different kind of machine over there to be able to test it. You can just it's scalable. You can actually have a many instances running and then test your OS image over there. So here's a few slides I try to add after I talk to several folks in this room, and then I think there's already CI FreeBSD.org here. So I actually doesn't know the answer of the difference between this and CI FreeBSD.org, because in the past I didn't involve into any development of FreeBSD OS image. But there's a good thing is we can, right now it's a AI era, so we can do this. So I tried to do this yesterday to do my homework. Okay, so yeah, ChatGPT, like a clear mention, like a CI FreeBSD is a Jenkins-based solution, and I know what Jenkins is. So here's some, like a difference between CI FreeBSD.org and Azure DevOps. So the first thing is the triggering mechanism right now is designed differently. So as far as I know, CI FreeBSD.org right now, it runs on specific branches or it's a schedule. So it's like every few hours, like it will run a task to build the OS image. And Azure DevOps would be more like on-demand request, like a pull request, every pull request or a different branch you want to request like a build. It's just one click away, and then you just one click there. You can request the OS image build immediately from your pull request, and you will see the status update over there. And second is a build environment infrastructure. So as I say, if you are running your CI system, usually it requires setup. You need to provide a server inside your data center or something. You need to have a dedicated machine to do it. And Azure DevOps, we are more like using cloud instance to run the test. So first is capable of migration. As I say, you can migrate these things into. You can actually set up this thing in your ecosystem, in your system, like your cluster, with just one file. You just copy one file over and then just modify a few settings, like 2 or 3, and then you will start you will build this pipeline, like a build pipeline setup with all your things, like your subscription, your instance, your Azure account. And then it could be adjusted anytime because it will be all cloud instances. So like FreeBSD is always image. So it's not like a small web server. So it build only takes like a few 5 to 10 minutes. So it require. So for example, I'm using a 32 cores CPU machine, 32 RAM, 32 gigabytes RAM to build the OS image. It still require, if you are building from the scratch, it still require an hour to build it. So in this kind of context, this machine can be adjustable. Like if there's if in the future that it's being used more and more, or in your company like you use this kind of building a lot, you can adjust the machine spec anytime. You just need to turn off your VM, and then you can change size of your VM and turn it back on. And your builder instance will be even larger after the job by job. And you can even provide the pool of a builder, so it will just automatically allocate the tasks into different builder according to the tech you are doing. So for example, if you are trying to build OS image with some compiler optimization, you like optimizing usually when you turn on optimization in compiler settings, it will take an even longer time. So you can adjust you can just apply different tech to get more powerful machine to be there. And then third is about testing and deploy automatic. So testing and deployment automation here, for the testing, the CI FreeBSD.org will be more focused on like a FreeBSD feature itself. On Azure DevOps, the pipeline we are introducing today, it will more focus on the releasing to the cloud. So it will be mainly focus on the cloud compatibility stuff. So you make sure before because you always have a destination over there. So you can use this pipeline to test those compatibility issues before that. So like for example, when Wei was testing about ARM64, he always had to a manual to build ARM64 separately, maybe in your local computer to verify the Azure capability. But he need to always go through a lot of manual steps to put that image, publish that image onto his Azure account, and then to start a VM and test a lot of things. But this can be done with Azure easily with Azure integration. So it will be fully automatic. So start this pipeline inside there. There will be ARM64 server over there. So you will know when you publish this OS image. When you start an Azure virtual machine, you wouldn't have problem there because you test it beforehand. Okay, so here's a very, very simplified architecture overview of this FreeBSD CI pipeline. Because the source code hosting is on GitHub, so actually there was 2 options to run the CI pipeline on GitHub. One is called GitHub Actions, probably more familiar with by anyone using GitHub. But that one unfortunately doesn't support FreeBSD scenario right now. But Azure DevOps, it can support this FreeBSD scenario. So and we do have integration. I noticed this one because it was right after acquisition of GitHub by Microsoft before, when when acquisition down in the first 1 or 2 years, they are doing this kind of integration to Azure DevOps service. So at the time we know there's a pipeline support from GitHub. So in GitHub report request, you can actually trigger Azure DevOps pipeline over there. So normally you won't be able to see because it will be more internal stuff. because Azure DevOps pipeline usually is not public facing. It usually is like a belong to some organization. So you only get to see those pipeline in GitHub project if that's an internal project. So you won't be you will be able to see easily on like a public project. But actually, if you are an open source project, when you have a binding like with your MS account, when you have a binding on ADO, it will give you an option that you will have a form you can just fill it out to apply like I think they provide one free instance, like a auto like the builder, and that one doesn't support FreeBSD yet, but they will provide one builder resources over there for free, but it's a very small instance, probably with only 2 gigabytes RAM, which is not very efficient for building an OS like an OS image like this. But if you are building other project, you can definitely have opportunities that you can actually apply one free instance, so you can have Azure DevOps pipeline to run for your like a public repository on GitHub. And the release destination will be Azure Community Gallery. So that's like a repository to host your snapshot of OS image, and then we will talk about that later. Okay, so so this is about this is introduction to Azure DevOps pipeline. So somebody never use it. I think it's kind of like a 90% of people in this room. So it will be starting with a simple configuration file. It's called Azure. It's always called Azure type pipeline.yaml file. Is in YAML format. So I just put it here so you can have some concept about this file. It will be a YAML file. You can define like where your machine run and then what's the step. So step by step, like this script task, and then you can just put it like this one. So to define your jobs when you are trying to use a CI pipeline, and then so this is why it's migratable, because you just need to copy file into your repository, and then when you are trying to build it in Azure DevOps, it will be available for you. You will run all the task for you, and then you will target your machine pool. And then so it actually has a very well-designed workflow engine over there, so it can handle a lot of complicated, nasty tasks. So you can have a lot of tasks there, and then try to fetch information from the different tasks. And also in the between, you can actually swap out for example, if you are doing some tooling, you might want to test other services as well, working with your virtual machine, and which is not 3D based, you can swap out the middle task to run on different kind of machine, like a Linux machine or something, and then test it, and then aggregate the result in the end. And then the most important thing is it supports self-hosted agents, so you can actually provide instance by yourself. So you can run those tasks. That's how we can achieve like FreeBSD instance by just hosting self-hosted agents on our Azure subscription. So so the self-hosted agent is actually based on this repository. It's called Microsoft Azure Pipelines Agents on GitHub. So it's actually open source. And then we just operate this agent on a FreeBSD virtual machine on Azure, so to be able to provide the builder resources for FreeBSD. But I want to mention one thing is the self-hosted agent is actually not officially supported by Microsoft so far. So this is actually an ongoing collaboration within the community, which is this pull request I attach on the bottom of this slide is called adjustment for FreeBSD. That's a contributor, J operator. I'm not sure whether you're here, but because it's on internet, it's always like an ID to us. And then this pull request starting like 3 years ago, and Microsoft never merged it because there's always we need some business justification to merge this kind of requests to support the FreeBSD ecosystem. And then we are using the instance from this pull request at this time and try to build this Azure pipeline support. So yeah, thanks for the contributor. There's a lot of ongoing discussion inside this right yet. So but it provide all the like a setup, FreeBSD requires setup steps, and in there to set up an agent is pretty straightforward. So yeah, so this is the one point is not officially supported yet, but right now we can do it from the community because it's kind of like open source. So so here's thing how we build the FreeBSD OS image on Azure. So first we need to create OS image like we built from FreeBSD SRC, and then we need to use a script to set it up as an Azure instance. So it mark the OS image as an Azure one, but actually it works the same. We don't have to mark it to be able to run Azure, but it's better we mark it this way. And then we upload this OS image to a shared image gallery in Azure, so we can see in the subscription. And then we will utilize the Azure VM as a testing environment using that published image. This will be the procedure. Yeah. So after you have the integration to Azure DevOps pipeline, you will see like this is like the prototype repository. So this is just simply the fork of a FreeBSD SRC under my account. So that shows the like a possibility we don't have to set up anywhere. I just need to copy to my account, and then I can have an integration like this. So yeah, the screen is too small, I know, because originally expect the canvas would be like at least this window. So I put it I put it like this. I'm sorry about that, but yeah, you can see there's actually a green like check mark here. Oh, I can point it. Yeah, the green check mark over here. So when you have the Azure DevOps pipeline set up here, every commit on your commit history in your GitHub will show the result over here. So you have a better idea like when the build breaks. So you can trace back into the trace back to the right revision to be able to fix your bug over there. That's pretty important for like especially a repository with a lot of different contributors. Sometimes we break the we checking and then we don't know it breaks. And then but also with this one, even before the pull request, when you submit the pull request, there will be a checking get over there. So it will guide your repository to be free of like this build break if it's configured correctly and testing out all the things over there. But at least the build break is very easy to detect because the build breaks, it breaks. So you won't be able to build. So you won't be able to proceed without it. The harder part will be in testing. And then also it will have a better like a summarized overview of all the tests or all the build tasks running over here. So it will tell you like also it tell you like what's the duration of this text, like this one. It's a man. It takes like 45 minutes and tell you like on which steps like this one takes 3 minutes, this one takes like 23 minutes, and the publishing take like 70 minutes for you to have a better idea like what happened over there. So this is when you click the detail, it will bring you to Azure DevOps. So for this one, this is somewhere different. Like you need to have the access, the permission to enter this project. So it's probably guarded by your subscription. So you need to be in the subscription to be able to see this page. So it provides you the actual instance inside ADO like of your build jobs. So as you can see, like this is all the job building on FreeBSD SRC, and then it will queue the request over there. So you can also request a new run over here. So you can actually run if you have more setting config inside your custom image build. You can actually supply the option over there. When you click the run pipeline, it will provide you the option over there, so you can customize your build if you want to test a different thing. Because usually when we are running a CI pipeline, you don't always want to enable full setting on there. But if you know your change is going to affect something, you can provide some. You can setting out some configuration to be optional, like optional task, and then you can configure it to be run over here. So like I will show you in the face later on. But when you click into a task, you will see there's like a visualization of your jobs, and like it will be grouped by the job, and then in the job there's a lot of tasks. So every step you will be able to see all the log, and the log will be out like will be sustained over there. So if you want to go back to see like maybe a month ago or like 2 months ago, like the build has something over there, you want to check all the settings over there. Usually it's very useful to check about like a compiler settings over there, because it shows all the parameter to your commands. This is a very good place to start to investigate like what happened over there, and then what's the result. So, and then also it can be, those tests can be either in like you can do it interactively, or you can it can be parallel. And then here's like since we support like a multi-architecture here, so we actually provide option like this one. So I put this one like there's an architecture setting over there, so you can actually select the architecture over there. It's not all supported yet. This is all the way I pulled from the FreeBSD CI build script. So there's all the parameter over there. So I just copy over, but it's not right now. I'm just making sure the MD64 ARM64 is working, and more thing is depend on like an instance. Like for example, like PowerPC, we probably need probably it can be built, but we didn't have like PowerPC instance on Azure, so we cannot test it there. Yeah. So you can so one more thing to do is like actually, as I say, the task can be parallel. So on ADO, you can actually have like a graph, like it will be parallel. Like you can build all your tasks, like it can be parallel executed. So you will have all your tasks ran efficiently. And one thing about the testing, because right now you have multi-architecture, you have a different kind of revision, and you have all the tests around there. You probably have 100 tests, 1,000 tests over there. So there will be always a testing matrix. It's just like a Cartesian product. Like you need to test all the combination every time to make sure it works. So if you are just validating, if you don't trigger the CI build over there testing on your machine, it will be you would need to like run through all the tests over there every time, and then you need to verify MD64 first. So this all requires starting a VM. So it requires you to, even you can only get a OSDB view, you still need to go on Azure and then start a VM instance like this too, and run all the tests over there. So for different view, you need to start over once, and like another view, you need to start over another once. So this can be automated in Azure DevOps. So all those things, the message is triggered every time when you have a build job over there. And then Azure DevOps provide aggregated like a very informative view on your test result. And then this is the only thing I don't have a markup. I don't have a screenshot right now, so this is just a markup from a document. But it gives you a better idea. It's an example of the test result. How would a test result be displayed? So first, right now the test under FreeBSD SRC, a lot of especially the test you want to run on when you start a Azure VM, the test result will be aggregated into JUnit, and that one is actually supported by Azure DevOps. Azure DevOps support like a file6 test format. So if you have the test result file, you can publish the test result file within your Azure pipeline definitions. So just tell the system where to find those test results, and it will automatically like show you like if you have different stage, you will display like this one, and it will tell you like what percentage of tests you passed. And then when you click into any stage like you are trying to see, you will tell you like very detail on the task, like if you have imagine you have this is very normal like a test is when you have a service inside Microsoft, and you want to look into like narrow it down into specific tests or like what failed. You can have it has a field like a filter lines over there, so you can see the failed one. Even for a successful one, you want to see, you still have a filter over there. You can look into specific tests, and then when you click into that, it brings you to the log view over there. So all the error message, successful message will be remain in that place, so you will be able to see like what's the test result over there. Because sometimes we probably don't trigger error, but the successful information is still important over there, so you will be able to see logs over there. And so all those regressions, like especially sometimes it's performance like issues. You want to aggregate some like a matrix over there to be able to detect those regression. It will be spotted when this test run automatically every build by build. So you have all the test result over there, so to be able to let you compare the performance data over there. The last step would be publishing the FreeBSD OS image into Azure Community Gallery. So this is like this is the interface showing you a community gallery. So you can see there's a name over there. It's automatically generated. It's over here. So it's actually this OS image are automatically generated by the pipeline. So every time when I'm actually not making any change to the FreeBSD SRC. I'm just modifying the pipeline file. So every time when I have a commit jetting, it generates one OS snapshot automatically. So like I'm just testing file, but it still has like a lot of like OS image generated because it's very easy under this pipeline. So when you have this one, so right now in the pipeline, it actually create a test of VM and then run all the tests, run the tests automatically. But right now, if you are trying to replicate issues, sometimes you might want to go back to see that image you publish. So if you go back to see your image you publish it there under your image definition, there's a single button over here to combine. Just click this one to create a VM out of from the image. So it's just one click. So there might be some confusion between like marketplace and community gallery. So what's the difference between these two? The marketplace is a term on Azure, which is like a more like a for official release. So it's like a FreeBSD Foundation publish FreeBSD OS image. So it's a public. It's more like a public distribution of the image, so that you can use. You know, there's a verified source of image that you can use. So and it requires more check because it will require some compliance with there's a Azure Marketplace publishing standard. So like for example, like when publishing this one into Marketplace from FreeBSD Foundations, there's additional steps you need to have a certification to make sure this image is done right, so to be able to use for all the Azure users. But Compute Gallery is something that is a feature for you if you have an Azure subscription. It's more for you yourself to manage all your OS image over there. So you have a freedom to publish anything inside the gallery that is also not accessible from outside. So it will be safe in your repository. And it's more ideal for like internal use, or you want to share with some specific like a partner or something. So there's more access control on that. You can do one is like a public. You can do a community gallery. Also, you can do privately like a direct shared image gallery with a subscription. So you can share with like if you have a partner working with you like a different company that you can use. We call it RBAC, role-based access control. You can give permission for others to be able to use your share the image. So this very straightforward method that you can share your image with like a developers, like maybe FreeBSD developer or maybe like your project developer, and also with Microsoft. If there's an issue on Azure, then you can just using this one to share your image with Microsoft to be able to test out your OS image. Okay, here's today's talk. So I'm okay. It's actually 10 o'clock. So yeah, but I think we have a long break, so I can take questions here. Oh. Yeah, well, let's see. What? What's the last thing? Seriously, I'm not sure about that CI, but I guess you are comparing about like you GitHub Overflow. You mean GitHub Actions, right? Yeah, GitHub Action. Um, so right now the most important thing is, for example, like Azure pipeline was inside Azure DevOps, so it can be more useful when your project is hosting on Azure DevOps. But right now it's hosting on GitHub. So actually, it's just two options for you to do the CI thing on your GitHub. But one important thing right now here is the GitHub Action agent. You can also do self-hosted agent, but that agent doesn't support FreeBSD yet. So because the .NET support right on it is not it's not finished yet. So the GitHub Action actually cannot be the option here. So that's why we use Azure DevOps. And also Azure DevOps has a better integration with the Azure Cloud. So for example, like if you are triggering some Azure operation with Azure CLI, so in other CI like GitHub Action, GitHub Action might do have some integration so far, but for full feature like all the Azure related stuff, you can expect like you don't have to configure additional things like a credential, those kind of thing, is all is being integrated with Azure DevOps for a long time. So all those like Azure CLI tasks can be executed seamlessly. You don't have to put extra effort to make it work inside ADO task. Yeah. Does that answer your question? Yeah. And any other questions? Okay, thank you. And yeah, feel free to catch me after this meeting and then to discuss if you have a specific scenario you want to discuss. Yeah, and here's my email, and then you can also feel free to send me. And even you want to contact some other guys I mentioned in the first slides. Yeah, and here's my closer view to my shoes. Yeah, to make sure it's the same as the Beasties one. Okay, thank you.
With George's talk. A quick note for questions. We only have one mic, and in order to be able to capture the questions on the stream, what we're going to ask is that when George is ready for questions, if you have a question, just come up and line up along this the side here, and we'll share the mic between questions and answers. And with that, I'll turn it over. Thank you.
All right, so I'm told to speak directly into the microphone, so I'll do my very best not to do this. Hi, for those of you who don't know me, I'm George Neville-Neil. I am a graduate student. That was supposed to get a bigger laugh. Anyway, I am actually a graduate student, crazily enough. And this is research I've been doing with my advisors, Robert Soleil, Peter Alvaro, another graduate, Stelios, and Avi Silberschatz. And so this is called OSDB, Turning the Tables on Kernel Data. So this is a general slide that you probably don't need. Wow, I got it like this far up. It feels rude. Anyway, y'all don't probably need to see this one since you actually understand operating systems, but later this year, the paper that we wrote got accepted to a database conference where I have to explain to database people how operating systems work. So I think we can get past this, but we all know that the OS is basically system calls and stuff, OS state and stuff, and device driver stuff. And these stacks are not to scale because 60% of FreeBSD is device drivers, and if we didn't have ZFS in the kernel, it'd be 80%. So all those other things in that FreeBSD book that guy wrote, it's mostly device drivers. So part of what motivated this work, well, I should probably face the cameras. Part of what motivated this work was to try and think about how we could use databases and database technology for telemetry. So what were some of the use cases we came up with? Well, this is a classic one. You run a program and you get EADDR in use, and then you're like, oh, on this really busy server, who is sitting on that port? And everyone in this room, of course, knows the answer, which is, you know, PS plus this, plus grep, plus whatever. And if you're on Linux, you can do LSOF, but if you're on FreeBSD, you do something else. But this led us to a bunch of questions, right? So if you are not someone who has spent the last however many years doing operating systems, and you are presented with a problem with operating system state in the operating system, how do you find that out? What do you do? Do you use PS? Do you use netstat? How do you find a manual page? And now that I'm doing graduate work and I'm actually helping undergraduates and young graduate students to do OS research, these questions come up all the time because they don't spend their lives diddling around with POSIX like operating systems. They spend their time in other places. Soon they'll be spending their time on AI, but let's not think about that. So, and then what are the options? I love this. Like, is it PS minus EF? Is it AUX? Is it something else? How many options are there to LS, as Kirk mentioned yesterday? We have this, and so we have this set of commands, this ad hoc set of commands that have been developed over the last 50 years to extract state from the kernel. And then what do we extract it as? Strings. Wow, that's great. So then what do? Then you run grep, and then you run awk, and then you run something else to try and actually get something out of it. So you have an operating system kernel that we collectively have built, with real structure in it, and then you remove all of that structure and you turn it into a string and you throw it into user space and good luck. So trying to figure out what's going on becomes a text processing job, which turns out was what Unix was originally written for, text processing. And then there's a lack of what database people call join. So let's see, on the left I have the output of PS, and on the right I have the output of netstat, right? And how do I try and correlate data from the networking stack coming out of netstat with data about processes coming out of the process table? Well, at the moment, I do it with awk, a tool that is older than half the room and almost as old as I am. So there's this lack of join. You can't really look at the data structures in the kernel and say, oh, I know that this and this column of data are related. Show me what happens when I join them. And to database people, that's really important. And it's a very powerful component of relational algebra and databases. And it's amusing. I'm going to say this in this crowd. I will not say this to the database people. I have hated databases my entire career. I think they are the most boring structures you are ever going to use. And really, I never wanted to program them, and now they're part of my thesis. So karma sucks. All right, so what was the observation? Why did we do this work? So the kernel is a database, right? There's a whole bunch of data structures in the kernel that look exactly like what a database person would call a table. They're generally lists of structures, C structures. And the really nice thing in FreeBSD, and I have not looked at the kernel port that's being done by someone else for this stuff on Linux, is that they're almost all in one file. Everything in q.h, lists, tail queues, all of those things, that's just a table. Because it's just a list of structures, and every single structure is a tuple in the table, and it all just looks like that. So the kernel actually is a database. It has many different tables in it with an awful API. Right? So, oh, I needed to get at this thing. Oh, I added another system call. I need to get this thing. I added another system call. So now we have 500 system calls in FreeBSD to extract this data from the operating system kernel, data that is actually in a nice natural format for processing. But then we turn it into strings, and then we put it in user space, and then we tell people good luck. So what did we do? Well, we did this. Oh, and I get to hand these out now. Now, if you are allergic to peanuts, don't eat these. Okay? We'll make the warning now. But for those of you who are old enough to remember the commercial, you got your chocolate on my peanut butter, or you got your operating system on my database. No, you have your database in my operating system, and this is what we did. Yeah, it even has a moving GIF. Terrifying. But there's this natural tension between the way operating system developers develop operating systems and the way database people view databases. Databases are top-down. You state your constraints at the beginning. The database will operate in this way, locking, which database locking and what we do for locking are different. I'll mention that later. How you lock records, how you deal with various problems of constraints in the database is a top-down problem. That's how database people have thought about this for the last, however, 50 years. And also the one nice thing that the database people have is they have math. So relations are real mathematical things. Operating systems don't have math. Operating systems are bottom-up, which is good luck with that hardware. Like, oh, here's a new platform. I hope you can make your operating system that looks like a PDP-11 run on it again. And they have to handle asynchrony. Like, now, databases developed by people like Oracle, not that I want to mention that word, but databases that run directly on hardware and not on top of an operating system obviously need to solve the operating system problems, right? They need to deal with asynchrony. But operating systems writ large, like FreeBSD, that's what we do all day, right? All we do is like, oh, crap, a packet came in, and now I've got to react to it. And database people don't really think about this when they're designing their systems. So when we took the chocolate and the peanut butter and we put them in the same cup, we had to handle these problems. So how does this look visually? Well, this is the operating system view of the world. And it's like, oh, okay, well, keep all the plates flying, and if one of them falls, it's a panic. And then this is the database view of the world. You've got this nice regular data, and it comes in, and you can extract it. And the other nice thing, and there's a great talk by one of my advisors, Peter Alvaro, at Strangeloop a bunch of years ago, where he pointed out, in databases, the time is always now. And you can stop a database. Now, people using it would get really annoyed, but it will not destroy the constraints of the database to stop the database for some period of time and do an operation. Try that in the OS kernel. That's very bad. I mean, we stop it for very short periods of time. So we have this tension between these two ways of thinking about it. So, yep, that's what I wanted. Okay, so what did we want to do? So we wanted to basically take this thing called the operating system and evolve it so that the state of the operating system could be investigated instead of with ad hoc mechanisms or with strings using a query language. And of course, in databases, SQL is the query language. So how do we make it so that people can look at the state of the system via SQL and then not only look at the state, but actually be able to update the state? So I'll talk about how we did that. So some implementation details. I don't know which one of these is peanut butter and which one is chocolate. I happen to like chocolate better, so therefore FreeBSD is chocolate, and SQLite is peanut butter, but whichever way you look at it. We took SQLite, which is an embeddable SQL database used in, it turns out, everything. Like, you build Python, SQLite's in it. You build LLDB, GDB, like a lot of things just have SQLite built in, except operating system kernels, for a bunch of reasons. So we had to port SQLite into FreeBSD. And then we used, it has this thing called foreign tables. I'll talk about that in a moment because it's key to how we did this. But we made it run in the FreeBSD kernel. We have a fork? We have a branch of FreeBSD. And we had to make some changes to SQLite, but not that many. You all know what FreeBSD is. So virtual tables. So what did we want to do? We know that these lists and these structures, and I'll talk a lot about the process list because it's a really easy example. Although, can anybody guess how many rows are in struct proc? John did that. That's great. It's not 100. It's only 98. Oh yeah, yeah. There are 98 columns if you were to expose the entire row of each struct proc. So virtual tables are these things, and it's actually a general concept in databases, but they're well supported in SQLite, where instead of having to have a real table backed by a B-tree structure, which is how SQLite stores its real tables, if you're in SQLite and you're like, create table foo with this, you get a B-tree. But you can play this little magical game where you have a set of methods and you can expose struct proc. You notice I only have the first 4 elements as a table. And then you can do all the things that SQL allows you to do. You can select, you can join, and you can update. So what we don't do, and I think I'll talk about it now instead of later, is we don't replace the process table with a database table. In fact, Mike Stonebreaker, who did some work on databases at some point, won a Turing Award, I don't know, some guy from Berkeley, has proposed actually replacing operating systems purely with a query engine for a database. Like, I don't need an operating system, I just have this database thing. He's wrong, but I don't get to tell him that until January, when he's probably going to ask some really hard questions. So we didn't replace any of the tables in the kernel with SQLite database tables. We simply expose those data structures as if they are tables. So then we have this problem of locking, because it'd be really bad if in the middle of some update, some other part of the kernel which was also running did something bad. And we have 2 types of locking, right? So everyone's really familiar with this. Everyone in this room is really familiar with this. You can lock the process table. You can lock the TCP sockets. You can lock the file system. You can lock a vnode. But then you also have to worry about the database itself, because you have in databases the same problem of time of check to time of use, right? I went and I looked at some piece of data and now I'm going to make a decision based on it. What if the data changed? And I'll talk about how we handled that. For the operating system locking, we simply exploited all the locks that FreeBSD already has, because those are all correct, I hope. And we just followed the same locking discipline. So we lock the process table using the same thing that everything else in the kernel locks the process table with. We do one little trick, well, a couple little tricks. But one of the things that we do is currently when we want to get data from the kernel, we grab all of the locks that we possibly can, and we, I should not watch John while I'm doing this, and then we snapshot the data so that the queries don't actually operate on live data. They operate on data a few milliseconds ago, and that's safer. So we respect the existing kernel locks, because if we didn't, the kernel would panic. And then we do the snapshotting technique, right? So when we take a snapshot, I think the screen doesn't like me. When we take a snapshot, we get what we call a transactionally consistent view of the kernel state. And this is really useful for a bunch of reasons. One is, so if you think about the way that we currently interrogate the kernel, usually we're doing it through a pipeline, which means that each program runs independently and sends its output to another program. So if I were to look at the process table, then the socket table, then this table, then this table, each one of those things would be grabbed milliseconds apart. By doing it all in the kernel, it's much faster and we get a much finer granularity of snapshots. Things are much more correlated. And then the other nice thing about snapshots is we get this straightforward time series over the state. So some people have tried to do this in user space. There's something called OS Query, which runs on Linux. And it sucks all the stuff out in text, and then it munges the text, and then it uses SQLite as well, because everyone uses SQLite, to do this in user space. But what we have are snapshots in the kernel. So every time you do a query, you get a snapshot. Of course, we added a routine that's like, every however many ticks or whatever you want to do, take a snapshot of the state, so that you can then walk backwards, right? You can be like, oh, what happened to this socket over time? Or what happened to this process over time? And you don't have to run a bunch of user level code. You're doing it all in the kernel. It's a, it's a, not round robin. It's a ring. So we don't eat all of the kernel memory, although the initial implementation did. So I fixed that. But now you can define, oh, I'd like 100 snapshots, 1,000 snapshots, whatever. If you're on a server, you can have a lot of snapshots. But anyway, any read-only query over a snapshot or across snapshots is what we call serializable. This is a database thing. So, but we have this time of check to time of use problem, right? So I do a query and I'm like, oh, well, so for instance, which process is using the most network resources defined as, the amount of messages sent by in the R usage block in the thread. Well, of course, if something's active, every time you take a snapshot, it's going to change. So you have to make this decision of, because in databases, the way they would do it is they'd be like, I take a snapshot, and I take a second snapshot, and I do a hash over the two, and if the hashes match, then nothing changed, and I can move forward with my update operation. This is only for updates or deletions, not for reads. But of course, going back to our earlier slide, operating systems change constantly, and they are asynchronous, right? It's not like time can ever stop. So we have to make decisions about the data that we expose to the user, whether or not that data can be used in certain routines. Now, at the moment, because we're only exposing the kernel data structures and not replacing them with tables, with true tables, we can also make it so that the methods, like update and delete, use the kernel's routines. So for instance, I think I've got this in here, but there's something in the paper where we're like, oh, well, now we have a network killer. So everyone knows what the out-of-memory killer is, right? So when something uses too much memory, the kernel's like, oh, by the way, oh, that was loud. But we don't have that for networking. So what if something is eating the entire network? And that never happens, Netflix, on anything on FreeBSD. So how would we do that? Well, we could do the thing of directly manipulating the process table, but that's not what we do. We use the kernel's internal, effectively the equivalent of kill, right, to be like kill, because that means that all of the kernel locking is taken care of by someone else. But we still have this time of check to time of use for the database itself. And we do what's called opportunistic concurrency control. This is a fairly old idea. I think the paper is from the 80s. And the idea is that in systems that don't have a huge amount of change, not operating systems, you take it, exactly what we've been talking about the whole time. You take a snapshot, you take a second snapshot, you compare them. They have a bunch of different ways of doing it in the paper. The paper's quite long. We do it simply. We're like snapshot, hash, compare. And then we decide which columns of data, which is which parts of the tuple, which is which parts of the C structure are acceptable, right? And at the moment, we're working through a lot of that. So this is kind of what I just said. Basic OCC is the queries execute over a fresh snapshot, and then before committing, the database people say commit, and I'm like, yeah, you mean before calling kill. We check changes, and then if they exist, we abort. And we do a lot of this for the obvious reason. So as a room full of OS developers, when we say something like, I'm going to take a lock, it's not this, right? It's like, oh, there's a mutex. I'm going to hold that until I'm done. If we did that in our system, the kernel would panic because we'd hold locks way too long. You just couldn't do it. So this is why we operate only on snapshots. And then this very last line is the important thing about dynamism. And one of the things we're looking at as the research continues is what are the right ways to handle what I call volatile data. although this seems to update the database people because it means something different for them. But basically, asynchronous data, or for instance, time. Right? Databases can use timestamps, but they're not driven by them. Operating systems are driven by time, right? Every single tick, there is another counter. And so you can never include a timestamp, even though we use timestamps in our tables, as part of the OCC, because it will always change. Then you would never be able to do an update. So, the first table we exposed, because it provided a lot of places to mess around, is the process table. Because you can kill things, and you can find things, and you can look at the threads, and you can find a whole bunch of data about the table. So in any POSIX-like operating system, including FreeBSD, the process table is the central point for a tremendous amount of information about everything going on in the system. In fact, the reason that there are 98 entries in struct proc is half the time when you add a new feature, it winds up in proc. You're like, oh, where are we going to put that proc? Now it's like thread, but it used to be proc. So we started looking at the process table. It's the one thing to rule them all and in the kernel bind them. So what does this look like? So for those of you who don't speak SQL, it's not that hard. It is really ugly. Like, you think COBOL's ugly? SQL is COBOL ugly, man. And you can now use lowercase, so that's nice, but generally keywords in SQL are lowercase. And this is just show me all the processes. So we've got this, it's not the full PS minus AUWX, blah, blah, blah. We've got some of the data here. But one of the cool things is we've got timestamps right in the snapshot. And that makes a lot of analysis easier because each snapshot is timestamped, and then we can do time series. But this should look familiar to anyone who's ever done PS. So for instance, one of the first things I brought up was, well, how do you find out who's got an open socket? So normally you'd use several programs, you'd run a pipeline. Young people would use Python, old people would use awk, and then cranky young people who are here would use awk, because that's what we're like. But how would you answer this question in SQL? Now, I'm not going to say this is beautiful, because it is not beautiful. But it is one line, and it is joining tables that until now could not be joined without going back into user space and through awk or Python or whatever. But because we've put this query engine into the kernel and exposed a set of tables, we can cross-reference, think of a join as a cross-reference, the process table, the TCP sockets, and the files. And that will then tell us the answer to our question, right? Who's sitting on my port? I mean, this is just an idle VM doing this. So one line instead of a pipeline. And also, I'll show something interesting, faster. So that's telemetry, that's reading the data. And then I talked about, how do we do things like updates or deletes. We talked about writes are only allowed where they don't violate the operating system state. So for instance, we never want to do something that causes there to be two of the same PID, because that would be bad. Or two of the same socket structure with the same tuple. So we want to be able to do things like, in the process table again, which is our first example that we went through, deleting a process in the process table should be the same as killing a process, right? So we can say delete from all procs where the PID is this. And that tells SQL, tells the virtual table implementation in the kernel, call this routine, we know that does the right thing. It's a kill routine. Yes? Okay. Wow. I feel this is very intimate. Well, look, dude, you're like, anyway. I don't even know this microphone. So, yeah, all right. So I'll try to stick with this. Anyway, so you can delete. So we can delete from all procs, and all procs is a list of all processes where the PID is this. But this is our one-liner for killing a network abuser, right? So this is delete from all procs where the PID is this, and then we select. And this is all typical SQL. You can go and do a search online for how would I do this kind of thing in SQL, and that's what I have to do because I never took a database class. And then it's like, okay, well, let's see, what is this? Where the PID is greater than 1,000, so it's not not in the secure group, and it sent more than 10,000 messages in the last second, right? Unix epic is part of SQL. And this is how we kill a misbehaving network process. This gives us the out-of-network killer. And I didn't have to add a ton of things to the kernel. I just had to add the small amount of code that we added for OSDB. So another classic problem, and John will enjoy this because we spent I don't know how many years at making things do this. Every once in a while, or pretty much every morning, someone puts two processes on the same core that shouldn't be there. And then you're like, oh, the tail latency just went. How'd that happen? So two processes may accidentally compete for a single resource. CPU is the one that we looked at for this particular paper. Finding and moving such a process is arduous, especially arduous when the ops group is screaming at you while you're trying to fix it. So again, we can do this in a single command because now we've exposed not only the process table, but the thread table. So our test for this, which is a nice simple test, is to run a couple of network perfs. iperf is a network perf test. Run the server. We, on purpose, put them both on the same core because we're trying to test this. And then we make our SQL query do the work. Find the two things that are eating this and move it. Again, I make no claims to the beauty of SQL, but the fact that this is one line instead of a pipeline of multiple scripting languages is pretty powerful. What was that? Yeah, there's that. Actually, it's the thing that makes a pipeline in SQL, and it's not a pipeline, but it's the select with the select with the select. You're like, oh. That's why I'm glad I work for someone who actually knows how to do this. So what's the performance overhead of this? How much do you pay? So this is something we thought was really interesting. Now we assumed putting a database in the kernel and wrapping some tables and some structures and adding extra locking because we had to lock the tables while we were extracting the snapshot, et cetera, et cetera, et cetera. We thought this would be really expensive. We just sort of assumed that throwing more code in the kernel wasn't going to be fast. Now it's not faster, but it's not as much slower, even by a long shot, than we thought. And so what we've been using is Unix Bench. And I would like to make a side comment since this is a Unix group of people. You know how old this stupid thing is? Like, a hobbyist magazine in 1983 came up with the benchmark we're all still using, and this is wrong. But I am not fixing this in my PhD. Someone else has to do a PhD to fix this. But we use Unix Bench for this. We have these big servers with 72 cores. What we found is, and what we looked at was, since we have a thing where we can say, collect samples at a certain rate, what is the overhead of collecting all of those samples? So the sampling frequency goes along the bottom. We've got 10 to the 1, 10 to the 2, whatever. Even out to here, these dots don't move, right? There's just very little overhead in collecting the snapshots, in part because we're not crossing the user kernel boundary a huge amount, but also in part because it turns out people who implement just databases understand data structures a little bit, and their code is relatively efficient and also operating on numbers. And it turns out computers really like numbers, and they hate strings. And I'll show a graph that shows that very clearly. And then we tried, what we tried to do, so when you're doing this kind of research, you're like, okay, well, it's great that one of the however many tests are in Unix Bench. You know, a whole bunch of these are like, there's no overhead. But you can't write a paper that says that. So you're like, okay, let's find the worst possible benchmark to put in the paper, which is what this is. And we found that there's this thing that executes a whole bunch of shells in parallel, just because in 1983, executing shells in parallel was expensive for Byte magazine. I don't know. Anyway, so the single core score does get worse as the number of shells increases. And you can see that here. That's the blue. But if you're using all the cores in parallel, and you actually fill all the cores, you still don't have a huge amount of overhead. And this is sampling from 1 to 100 hertz. So here's the interesting bit. There we go. We ran a test where we started thousands and thousands of processes. And we're like, okay, well, if we just do the simple thing of like select star from all procs or PS minus blah, 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 and we manipulated we used the arguments to PS that gave output that looked like we were getting in OSDB, like we sorted it in a particular way, and we were able to get them to match. The red line is PS. And this is how much worse PS gets as you get up to, I guess we went to about 7,000 processes. And you've got this, it's not exponential. I'm not a mathematician, but I asked a mathematician and he said it's superlinear. I'm like, okay, fine, it's superlinear. But it's not good, right? And why is that? Because this is not an expected result, right? You shoved a bunch of code in the kernel and you didn't really optimize it in particular, you just used it and it's faster. How on earth does that happen? Well, I say that in the next, no, I don't. I have to say that verbally. There's a couple of things. First of all, what does PS do? It sorts a bunch of strings. So if you ask PS to sort, it sucks all the text up into user space and then it runs sort on it, runs qsort on it. And if you use PMC, which is what I did to look this up, it's like, oh, that's hot. And you're like, oh, that's a bummer. Because it's operating on the, I would now argue, the wrong kind of data. OSDB, because it's using SQL, and the things in the table are numbers, can actually sort more quickly. And so almost all of this overhead is sorting strings. And that's why this is linear, I asked the mathematician, and this is superlinear. So it was just an interesting bit we got out of that. That if you operate on the kernel's native data types, integers, which is most of what's in the kernel, because we don't even allow float, but that's a different discussion, then you actually get better performance. So what else are we going to do with this? There is, I'll share the slides. If you haven't had enough of me speaking, there is an 8-minute demo of me demoing how all of this works online in a little video that I made. And then, so what are we going to do next? So, well, currently we have 7 tables, which took all of 4,500 lines of C. We were able to expose all of that. Now, that doesn't count the SQLite code, right? But we didn't modify SQLite. The modifications we made are 4,500 lines of code. And every new table is about 200 lines, depending on the size of the table and how much we wanted to do. In fact, as of this morning, one of the undergraduates we're working with, we've got 2 of them working on the project, was able to add a table for NFS. So for those of you who saw my questions on net about, hey, there's all these get adders, what's going on? Well, that was driven in part by teaching all of the folks how to do kernel development and build out of tree kernel modules, because we had this weird freeze. And then we said to one of the undergraduates for their, it's a 490 project, for their undergraduate project, we're like, why don't you try to figure out how this, what's broken, and try to figure it out the old-fashioned way, which took weeks, because it's like, oh, collect the NFS stats, collect the PCAP, have GNN read the PCAP, because who else reads PCAPs? It's one of those things. And now, he was able, over a day, to add an NFS table that instead of having to do NFS stat over and over and over again and grep it, just spits out a bunch of snapshots and is like, oh, that is the thing that's going up constantly. And that's the kind of thing that's really powerful about this. The other undergraduate we're working with has done something super cool, which is there is a Clang plugin, I guess, that someone built to start extracting things like the stuff in Q.H. He was actually working on OpenBSD. It's a collaborator we work with. But then one of our undergraduates took that, and now when he runs a kernel build, it extracts every single thing that is an S list, a tail queue. They just all get extracted as tables. And so there's 150 tables for me to go through when I get home. Because we still have to have a human going like, that's good, that's bad. So automatic structure extraction is useful because you think about this as, and what I now call this writ large is data tracing, right? So we're very used to doing function tracing, dtrace, BPF, a debugger, but generally we don't think about the data in a program as something that might be traced. And what we want, the reason we want automated structure extraction is every time you build the kernel, you get a whole bunch of debug information that goes into dtrace, and maybe you get all the tables, right? And then you're like, oh, okay, now I can build my own tools without having to add 500 more system calls. We're also looking at validation as a security mechanism because the relational algebra can be used to express constraints. So let's say you have a firewall. Well, currently firewall languages are ad hoc. Like, oh, I happen to like the way these strings work in PF or IPFW or in whatever the thing is on Linux, IP filters. But if you were to actually use relational logic, you could express the constraints of what could go into the table in a way that could be mathematically understood. Looking about doing a dtrace provider so we can connect data tracing to function tracing. There is a Linux port, a nascent Linux port. I think it only does the proc table so far. And they're looking at eBPF. We're looking at applications to containers. And I mentioned the application of firewalls and other kernel tables that should act as tables. So that's what we're doing. Are there any questions? You have to come to the mic. Oh, wait, we only have one mic. I guess I'm going to interview you.
If you go back to your slide where you showed the linear and superlinear, and I guess I'd never noticed when I run PS, I don't think PS naturally sorts, so you forced a sorting on it just to match your output, correct? What if you took that out and just accepted the native PS ordering? What's that graph look like?
So I actually don't have that graph with me, but it is still not as good because it's still dealing with strings. It is less superlinear. Yeah, it's more like here. But it's like an offset. Does that answer your question?
Does it work on kernel core file?
No, but I like that. It does not, but we could do that because we've got the state, right? We could keep the snapshots. And actually, the snapshots would be in the kernel state and we could find them, but I'd have to hook it up to DDB to make it find it.
Yeah, in my own experience, I was always wanted to do data tracing, usually on a dead kernel.
I will take that down when we're done. Actually, you had your hand up. Do you want to go next?
Yeah, just a quick question. Thanks, interesting work. How do you deal with structures that references other structure? How do you snapshot it?
That's another paper. So the question is, how do we deal with structures that reference other structures, which in FreeBSD, we do that all over the place. So there's the concept of a foreign key. One of the nice things in the kernel is an address is unique, right? Like in process space, we can both have the same address in two programs. But in the kernel, it's like if the address is FFFF whatever, so we can use that as a foreign key. But one of the things that is interesting and is part of the research is how do you find foreign keys and know they are foreign keys? And the problem with that is not automatable. In fact, so Avi, who's one of my advisors, did a ton of database stuff and the dinosaur book that we all know. Avi's comment is, no, you can't derive that. God has to whisper in your ear. I get really nervous when God is whispering in my ear because usually those people go out and like, that it's a problem. So we have not come up with a good solution to that. We can do it by hand. We'd be like, oh, this is a foreign key. But we can't derive it automatically.
So because you do joins between different tables, when you take a snapshot, do you have to lock all the tables simultaneously? So that's like a giant lock? Or because I wonder, like, for example, for process table, right? If we would like to, because what we are seeing is we have a problem with scalability when we hit around, like, I think 13,000 processes. The schedule really slows down. And this is because the process table has a single giant lock. Yes. Yeah. So I wonder if we would like to split it between like multiple locks, then you would have to take all the locks, right?
So it depends on the fidelity. So right now, because it's a research prototype, which is what graduate students always say, we do just grab all the locks because it was the easy thing to do. Not obviously, but we would have to do something very similar to what the kernel does. Like when you think about locking the routing table, right? So we'll lock the table, we find the route, we unlock the table, we lock the route, or we lock the route, we unlock the table, et cetera. We'd have to do that sort of flow to make it scale. Right now, like if I locked all the 150 that Brian extracted, I think the kernel would actually panic because we would take too many locks. And there is no longer a giant lock, but I would have just taken that if I could have. That was easy.
So if you do an update, right, and this is where you compare the snapshots, and when you abort, basically the update fails. That's the idea. And there is no like a notion of something like select for update, where you could like reference.
So that is part of the current. So this obviously this paper went in months ago because papers don't get accepted quickly. That is part of the current research. That's why we're trying to find out the foreign key stuff, because there's a question of, so it's very interesting to work with database people. I mean, they're very, like my advisors are very smart people, but they don't code operating systems all day. So they don't, I'm like, hey, what happens when this happens? Oh. So currently we're doing research where we try to figure out, and I've got sort of 3 broad areas of where the asynchrony and volatility come in the system, and we're like, well, can we decide that a particular column, which is a particular part of a structure, is always okay, right? And that's currently going to have to be decided by a human. Like a kernel developer would be like, oh, that's probably okay. But this time of check to time of use, so when you think about like killing a network daemon, not so much of a problem because you know the graph is doing this. But where you're moving a thing between cores, you could thrash. So do we include this column or don't we include this column? And under what conditions do we include the column? And that's what we're currently trying to work out now. You wanted to argue.
No, I'm not. I did say that last night, but I just said that because I know you. No, but the question I had was simple. On your future work for parsing kernel data structures, that's something that would be very useful if we could get it in a semantic form for 32-bit stuff on 64 or for emulating ARM on AMD 64 or whatever. The question is, you know, that's kind of they sound similar. Is that something that might be a product that I could use, or do I still need to have a block of time to do that, a similar sort of thing on my own?
So the semantic versus syntactic question. So we can get the syntax out, obviously, because compilers do that. Right. The semantic question comes back to the foreign key question, comes back to the God whispering in your ear. Thus far, we have not come up with a good way to structure a set of rules that extract semantics. Now, last week, we discussed having one of the other graduate students who happens to work on machine learning, which I will only call machine learning, come up with a classifier. So it is possible that we will be able to classify certain things. We'll try that. But that's very, very early. Syntax, I wouldn't say is easy. Syntax is straightforward. Semantics is very hard. Yeah.
That's the same problem I'm running into.
Yeah. Yes,
I was hoping you'd solve it for me.
not yet.
I want to follow up on the topic that Pavel brought up. So about locking, and so the locking mechanism can change. So for example, routing table is no longer locked as it used to be. It's now by epoch, and PCBs are protected by SMR, and this also can change. So absolutely crazy idea. Maybe John will say that this is possible or not. What if we run the thread, the kernel thread that fetches the data in such a concept that it actually can dereference null pointer without a panic? You catch that, and you say that you cannot follow this linked list. So very much like throws exception, catches exception, and then you can proceed all the data in kernel you got locklessly, and give the user land a snapshot of everything. You may have some stale data, but you still exactly. And you are absolutely agnostic of what is the current locking of this particular subsystem. So only what needs to be done is a faultable, catchable context in kernel. Is it possible?
Hold a camera and a mic. That's fine. So, no, they got me. Multitasking. Too many bad puns. So I'm trying to think. You could do something horrendous, where No, more horrendous, where you have a PCB on fault handler that long jumps to a jump buff that you have set jumped before. That might work. The only trick is, well, normally we call PCB on fault in a way, like we've called it before we've done any locks or other resources or, oh, you would go ahead, go for it, Ricky. Normally we do PCB on fault pretty safely because we're not acquired any locks or anything yet. So you could probably do a long jump from a PCB on fault handler. It's kind of interesting because all our current on fault handler is written in assembly, but you could branch to long jump. You need a global, and that kind of sucks. That's how it works for DDB. So when DDB takes a fault when you're inside the debugger, we effectively do a set jump, and we notice, and we kind of do a manual PCB on fault equivalent. We notice we're in the debugger, and we do a long jump back out to the global. So that part kind of sucks because finding the right jump buffer to use is kind of terrible. Maybe you could stick it in curthread. You could probably do something where you stuck something in curthread that's my current set jump buffer that you long jump back out to. No, but it's actually probably pretty trivial to make it a per thread thing and look it up because you can probably safely dereference curthread to find your jump buffer and your on fault handler and still all do that in assembly. Yeah, you should. Yeah, yes. Yeah, because you could the same way we do with other data structures. You could in this world under some evil kernel option, like I hate my kernel, you could. You could statically allocate a jump buff with thread creation, so it always lives around with it. We do that with like turnstiles and sleep queues now, so they always have a data structure that they can donate when they go to sleep. So you could do something where you associate a jump buff with a thread all the time. It's always there. It's always allocated and living, so you can set jump on it before you do something ridiculous and turn on and set a flag or something, which is if you get a fault. And so you can even not do it with PCB on fault. You can do the same places where trap handlers we call KDB reenter. You can check to see, it's one of your magic, I'm in a special fault and I don't really want to fault, where I will basically long jump to the magic thing if my flag is set on my thread. So you could do that.
Is there going to be a transcript of this? Because I need these.
I mean, there's a video.
Okay, good. We're okay on time, right?
So I was just wondering if you were looking at any changes to in-kernel data structures to natively just support the version information, similar to like what was motivated in the case of RCU, where you're already making a copy anyway in order to be able to provide additional concurrency. You could merge those two things together in the most critical data structures or whatever that you want to be able to export.
So on the flight here, I outlined 5 more papers I want to write, and 2 of them include converting actual kernel data structures to SQLite tables. So we are looking at that. I mean, of course, for me, it's all the examples are in the network stack because that's all I care about. I mean, I hear that the kernel does other stuff, but those are the ones I know. So we are looking at that, but that's a big lift. And so there's a question about how we would do that. Sorry. Anybody else? Oh, one more.
So with the locking of everything, I assume that's done all at the same time. And then the question would be, if you have a system that's highly loaded, say doing a lot of networking data, what's the effect of that on the system?
So at the moment, I cannot load the servers with enough stuff to make the kernel unhappy. Now, if someone wants to donate a $200,000 Ixia to Yale, then I will try to do that. But on relatively typical high-powered workloads, we just don't see that much trouble with the kernel. And at the moment, we're only locking 7 tables or 9 tables. Right? If we locked all 150 that have just been extracted, different things would happen. But the other thing to realize, and I have not gone over the extraction yet, I am pretty sure that 100 of the 150 tables are things that are in device drivers, right? So they're probably not in the main line of the kernel execution. Like the number of things that are like process table, the virtual memory, the things that are shared by everyone are probably the first 50. So we'll see how bad that is. But the other thing is that the snapshots are cheap. like all we're doing is copying a bunch of integers. We're not copying, you know, like even struct proc is, how many K is it? It's not that big. No. Each entry in struct proc that you copy is not huge, and on a modern server that's quick, right? Well, you need to lock the. We take the all proc lock. Anyway, thank you.
One more comment, because I.
Oh, there were no more questions.
So if you just grep for like tailq head, you'll find a lot of things that you probably don't need to do, but some of them will be redundant. So for example, sleep queues and turnstiles both use a global hash table that all the entries that you have buckets of tailqs that we stick threads in, but you don't need any of that because when you look at a thread or actually look at a thread, you know what sleep channel it's on by the member of struct thread, like Ted Debchan. And the same thing for if it's blocked on a lock, you know that from a member of the thread. So some things we do in the kernel, we store the data multiple ways, and in your case, you only need it once. So there's actually probably many of those 150 things that not only they might be device drivers, but the things you can ignore because they're a duplicate of what you already have. So the things that matter is probably much smaller. You probably have most of them already, honestly. Yeah, that's all hung off the process anyway. All right, so yeah, thanks, George. Okay, so we're going to take a break, and it's not 11:30 Pacific, it's 11:45 when we come back. So we'll be back in a little while for our next talk, but on a break. All right, folks. We're getting ready for our next talk for the day. Folks will make their way to their seats. So next up, we have Alice Sowerby from the FreeBSD Foundation, here to talk about laptops with FreeBSD, as Ed teased about yesterday. Go for it, Alice.
Thank you. Yeah, I feel like I got very heavily trailed yesterday, so no pressure. So it's great to be here. Really nice to see everyone here. This is my second time at a live event that involves FreeBSD, so it's really nice to see a few people that I've seen before and some new people as well, and people online. I won't think about them. So the talk today, learning as we grow, but now I look at it, I wonder if it should be growing as we learn, but you get the idea. Managing FreeBSD infrastructure and laptop projects as two different projects at the FreeBSD Foundation. So I'll just introduce myself for those who haven't met me before. My name's Alice Sowerby. I'm currently doing program management for the FreeBSD Foundation. I started that in June this year, so I think I can stop counting in weeks, but I'm definitely still counting in months, and was not involved with the FreeBSD community or project before that, so I'm kind of new to all of this in that sense. I'm British. I live in the UK, near to a town called Bath, or a city called Bath, which is, if you know where London is, you just need to go west for about an hour and a half, and that's where Bath is. It's a very nice historical city. It's very popular for day trips out of London. There's a Roman baths and Georgian architecture, very famous for Jane Austen. It's lovely. Yeah, very very popular. I'm a freelancer, so I'm on contract with the foundation currently. And then just a couple of little facts about what I do outside of work. I'm mainly driven by what pictures I could find. So you can see gardening. That's where I look like I'm, Second World War land girl. Dancing, that's why I'm doing some Latin dancing, which I like to do Latin ballroom, salsa, Argentine tango, you name it, I'll have a go. This is me at the EuroBSDCon. I had my picture taken by Olivier. And then just in case anyone wants to talk to me later and you need an icebreaker, you can ask, there's a tiny picture in the corner here. That's me and my two younger sisters in Chequers. Does anyone know what Chequers is? It's a UK reference. It's a place. It's a stately home. It's the Prime Minister's house. So you can ask me why was I there, and I'll tell you the answer, but not as part of this presentation. I have been probably actually closer to 20 than 15 years in tech. My career path has been meandering. I spent a good amount of time doing user experience design for B2B tech products, also including developer products, developer tooling. I've also done product roles, developer relations roles, and operations roles. So just wherever I thought I could be useful is I was following my curiosity. Some companies that I've worked for that you may have heard of, Equinix is one, my most recent role, which was program director for developer relations. DDN Storage, where I was working in a sort of an incubator startup role, doing operations. Sophos, that was my first employer in tech, because prior to that I was a high school teacher doing science. So my degree is chemistry, I'm not a technologist. And then I've worked in a couple of different startups. So when Docker got very popular in sort of 2014-ish, I was in a container-based startup, VC-backed, UK-based, but backed out of mainly American money. And machine learning ops about 5 years ago, before AI kind of took off. Open source-wise, obviously I'm now part of the FreeBSD community, but I'm also active in the Chaos community, and those folks who were at EuroBSDCon may have seen me giving a talk about Chaos there. It's community health analytics in open source software projects, which means that if you have an open source project and you want to understand, is it healthy, is it sustainable, there are things you can measure and then things you can do to see if it makes a difference to those measurements. And then you can work towards making your community a little bit more healthy and sustainable. And it's things like time to first response on tickets and various things, bug backlog closing and things like that. And then the to-do group is part of the Linux Foundation. It's a community of practice for open source program offices. So a lot of large corporations and governments have open source program offices that manage their use of open source and engagement with open source projects and foundations. So I'm a book editor for them, and I produce the podcast for Chaos. So I don't really use social media, but I have put my foundation email address here, and that QR code takes you to LinkedIn, which I do use a bit, not much. So today, as build, I'll be talking about how the foundation is using targeted investment to deliver specific outcomes for the FreeBSD project, how it's changing its staffing and its processes to manage these projects effectively, and 2 example projects, which is infrastructure modernization and laptop usability, and a deep dive into each one of those to look at the objectives and the benefits of the projects and how we're managing those, because it's slightly different for each one. So let's start by taking a look at targeted investments for specific outcomes. It's exciting. All right, so just a little recap of how sponsored projects have worked to date with the foundation. So you probably know better than I do the long history that the foundation has in sponsoring projects, particularly development projects. Okay, and you may be familiar with this page on the FreeBSD Foundation website, where it lists a lot of the projects that have been sponsored or funded by the foundation. They can be proposed by pretty much anybody. Sometimes they're initiated from within the foundation based on conversations. Sometimes people will write up proposals and we'll go through a process of evaluation, and the funding will come from there. And then funding has generally come from the general donation pool. So donations are not generally connected to the work, not generally. And if you see at the top, you can see that there's a donate now button, and the donors and the donations are all totted out there. And that's how it's been done up until now. And this is continuing, that we're not stopping doing it this way. But I'm going to speak a little bit about how we're extending from that model. So it seems as though there's something interesting going on in open source at the moment, which is that there seems to be a ramping up in interest in investing specifically into open source from various sources, right? That perhaps were doing it in a more ad hoc manner or weren't investing previously. And I've put on the right here a screenshot of an organization called the Sovereign Tech Fund. Now, something's wrong with this, so I don't know does anyone know what's wrong with this screenshot? If you've been following the news lately? Okay, it's changed its name. It's now called the Sovereign Tech Agency, because it's relatively recently been set up. It's about a couple of years old. It's a part of the German government, but actually their website is in English. And they invest in, as you can see here, open digital infrastructure. So organizations like the Sovereign Tech Agency yesterday, I think Ed mentioned the Alpha Omega project. which was part of, comes under the Linux Foundation, are now looking to invest specifically rather than just to donate. So that they're trying to influence or support certain key attributes of the open source ecosystem that maybe had previously been left to chance. So things like security and diversity within the infrastructure. So as I alluded to, it is more government and NGO-led than commercially driven, although there are certainly some commercial investments. The difference between just general donations and this type of investment is that the investment is much more structured, and the bodies that are investing are not necessarily looking at it as being a donation, but more of a commissioning of work or a commissioning of impact that they would like to see. And as part of that, they're looking for evidence. Okay, so it's not just, hope you do something nice with my donation. It's actually, they are trying to deliver evidence to their stakeholders that the money that's been committed into the open source ecosystem has actually produced a net benefit. And actually, I was recently asked to review a paper that was speaking about how that impact was actually measured, because that's not, it's not very mature as a practice, and that's still something that's being worked on. And actually, the Sovereign Tech Agency is one of the groups that has invested in FreeBSD project, and part of our work with them is to help them figure out how best to measure impact of investments. So they ask for a lot of feedback on lessons learned as well as impact delivered. So just to speak a bit more about the investment sources that we've been engaging with. You may have met Greg, potentially, Greg Wallace. He was hired last year into the foundation. He was with us for a year and a bit, perhaps a year and a half. And he did a lot of work to develop partnerships and to seek potential investors through those partnerships, whether they be commercial partners or NGO/government partners. And so 3 of the investments that are particularly noteworthy that came in through his work are, we had an investment from Quantum Leap Research, who are the main investor, apart from the foundation, into the laptop project. So they've given $250,000 into the laptop project, and the foundation's given $500,000. Then we've also had the Sovereign Tech Agency, which has given, it was 600 and some in euros, but it basically comes to around over $700,000, which is sizable. And then we had Alpha Omega, who funded some security-based projects, and that was around 138,000. So even though these have all come from slightly different sources, they've all been tied to outcomes that we've agreed up front what those outcomes will be. So I'll tell you a little bit more about each one of these. Alpha Omega I won't be going on to say any more about, but Quantum Leap Research, which is the laptop one, and Sovereign Tech Fund, which is the infrastructure modernization, I will be saying more about. So Alpha Omega, as mentioned, is I don't know whether this is the exact right use of the term NGO, but it is a non-governmental organization. Its funds have come from hyperscalers, so we've got AWS, Microsoft, and Google funding that. And their focus is on making sustainable security improvements in open source projects. The work that they commissioned from us were 2 things: a code audit, which was discussed yesterday on the Beehive hypervisor and Capsicum sandbox, also a process audit. And that project started in roughly the beginning of June and will finish roughly around December, but there are some extra bits that we'll probably do to follow on from that. And that project, all the information about that project can be found on the OpenSSF GitHub repo, and there are monthly public reports that we write that can be found there. Okay, so Quantum Leap Research is a private company. So it's based out of the US and does a lot of work with government agencies. That's about as much as I think that they wanted to share with us. So they don't talk much about their work publicly, but the laptop usability for FreeBSD is important to them. So they chose to make an investment on the condition that we would spend it particularly on laptop usability. The key things, and I will talk more about exactly what's in the project, but the key things are contemporary Wi-Fi, which I know is one of the top asks for laptop users, full audio, suspend and resume, which I know is another one of the key things, and other identified features, you'll find out. Then we're looking at the Sovereign Tech Agency. As I mentioned before, it's a government body, and we see that there are other governments who are doing similar, not identical projects. I think the Netherlands is doing something similar. What they're focusing on is digital sovereignty. So that really means that individuals, industry, and government are all able to have a choice, and particularly a choice around open source for their software supply chain or their software stacks. And the 5 projects that we have with them, or 5 work packages, cover zero trust builds, CI/CD automation, reducing technical debt, security controls, and SBOM improvements. So I will be saying a bit more about that one. So let's see how this is changing the way the foundation works. So on the left, we have sort of previous state, and on the right we have where we're going and what we're doing to change that. So previously, fundraising wasn't a sort of dedicated discipline within the foundation in the sense that it didn't have dedicated staff, and it was something that was done across the foundation staff, particularly by Deb. And where that's changed is through Greg's input. He was with us for a year or more. He helped to set up really a model for how to go about getting these targeted investments. And now that he is not in that role, we're taking those processes and then we're slotting in a new role which is based around grant writing, which is the main bit that we didn't have covered. In terms of project management or project processes, project staffing, we had one project manager. You may know Joe, and Joe was very much coordinating projects on the ground, so making sure that people who were or are working as contractors on specific funded projects by the foundation they know what they're working on and they're getting on with the work and reporting back and things like that. So that was where we were at before I joined. Now I've joined as technical program manager, so we have at least 2 dedicated project staff. And then this bottom section is relating to how are we running projects with the community? And it was a fairly sort of ad hoc, perhaps would be a good way of saying it. So volunteers would get involved as and when, individual contracted developers would get involved as and when, and it was really just depending on what the project needed. Now we're moving more towards a model for these larger projects that have very kind of specific outcomes in mind that we are using. We're not completely there yet, but we're getting closer to having more mixed project teams. So by that I mean that some people from the foundation are working, some contractors are working, and community stakeholders are working as well within those projects, which is very important for our intended outcomes of how we want to do the work. Processes, as previously mentioned, we never really had specific output required from investment, and the tracking spend was tracked, but it's at a fairly high level, like what money was being spent on. Now we're going much over to this idea of investment. Some of our investments, not all of them, requiring a specific output. And then I've also mentioned here project accounting, which is a little bit of a detail, but for us it's a big change in how we work, because tracking hours and how much time an individual person is spending on something is not something that was done before. But it does allow us to have a much more granular control over how much we're doing with the money we've got. So previously, in terms of the process on project management, projects were proposed by contractors and others, it should say and others. And usually it was one project, one contractor. Now the projects are larger and more strategic, and we're seeking additional investment sources. So sometimes, I don't think we've got any yet, but we're looking potentially to have some projects with multiple investors. The laptop has the foundation as one, so that technically is multiple. But we've got these multi-domain and multi-contractor projects. So when I start talking more about the infrastructure modernization, you'll see that it covers some disparate areas, and no one contractor or one volunteer is likely to have all the skills required or the knowledge to do all of those. And then we're also including third-party suppliers as well, because sometimes it's quicker, or it comes as it comes with its own sort of project management to hire us. So you will probably all use suppliers to have someone to come in and actually just deliver on a piece of work that you need doing. And that will make more sense when I start to give you an example. In terms of engaging the community, so yes, project updates certainly have been happening, and you will have seen those. And they may well have been coming out through marketing channels, which is absolutely fine, of course. The transparency of the proposal process and the ongoing work has not necessarily always been clear to everybody, and that is something that we've had feedback on, and we want to, we're working towards making that more transparent. We now have more process around reporting on these funded projects monthly, because pretty much all of our contracts require us to do that. That is a really great launchpad for us to be able to then share to everyone who has an interest, because we're already giving updates. So we can just take those updates and then share them more widely. We are making a point to include as much as possible and as early as possible the FreeBSD admin teams, and I'm talking about teams like core, source manager, port manager, sec team, release engineering, all the teams on the steering calls. So we're having, like bi-weekly steering calls for these projects, just to make sure that we're not working in a vacuum with our contractors, but we're actually ensuring that somebody who's representing the project has a view of what's happening and is involved in decision making. And then the other thing that we're doing is supporting the working groups, which does relate to these projects, because that's where we tend to get the wider view of where these projects are fitting in. So it's not just relying on those admin teams to give us the view of the project and what's needed, but also working with these working groups. Okay. So the first project to talk about is infrastructure modernization. It was difficult to come up with a name for the project that really said a lot and was short when we had so many different things in it. So hopefully infrastructure modernization sort of covers it. It started this year in August, so it's not been going too long. It's running for just over a year. and it'll be finishing up approximately September next year. As mentioned, the investor, and they don't like to be called donors, they like to be called investors, is a sovereign tech agency. I did change it there. Objectives are to, as you can see, up-level hygiene and security tooling of base and ports and packages, to modernize the project's infrastructure, to accelerate development cycles, to improve build security, to streamline the onboarding of new developers. So these are not necessarily what you would call kind of technical. They are technical. You need to be technical to do the work, but they're not focusing on like a particular subsystem or source code necessarily. It's more about making sustainable changes to the way that we do some things. And then the output is, I think I mentioned that before, but you can see technical debt reduction and so on. These letters are the identifiers for the work packages. So we have work package A, work package B, work package C. So you might see those referred to a little more as we go along. So how did we get them to give us the money? So this probably took over a year to do. So I think it was last year that we started engaging with them. They had an open call for proposals. This is the picture that they had on their website. And it was a 2-round process, which doesn't sound so bad, but they had some very clear ideas of how they wanted us to make the proposals to them. So they assigned us a project manager very early on. It was essentially a collaborative process to put that together as a proposal. And one thing that was very notable about this investment is that there was very much a time, a budget, and an output. So if you've been involved with any kind of project management or any kind of project like this before, you'll know that this is you can't just hope for the best. You kind of have to have a plan when you're going to go into something like this. And they've also given us defined areas of impact. So it's a little bit small, this text, I'm sorry, but I couldn't compress it because it's the exact contract wording. And I wanted to give you a sense of how we're looking at ownership of outcomes. So the Sovereign Tech Agency is not necessarily a user of FreeBSD. It might be, I haven't asked. But what they want, so we're not delivering something to them that we hand over and they say, thank you, it works perfectly, of course. We'll come back to you if there's any bugs. What they're doing is they're investing in the ecosystem, in the digital infrastructure ecosystem, to make it better for everyone. And so they have come to us to ask, what can you do with money to make it to make that overall better? So we proposed the things that aligned with their goals that would also align with our goals, and we came up with this contract wording that was actually very high level. And if you've ever seen a specification for a project, it's normally more than one slide, right? Particularly if it's going to be sort of this amount of money spent. What this means is that we have a lot of latitude. We have a lot of latitude to decide how to make that impact and to work with the project to decide how to make that impact. So we do have a few things. So it says perform bug triage and remediation, document patches and fixes, develop a comprehensive issue management program, assess and implement issue management tools and technologies. They're somewhat specific, but it really doesn't say like how many bugs we have to close or in which system. It doesn't say, what comprehensive means. It doesn't say what issue means. It doesn't say what management means. So it is very much as long as we can demonstrate that it's been valuable and it's within these areas, then the outcomes are ours to define. Okay. Okay. Just 1 second. So just a little calendar for you, a Gantt chart, where we see we started with A. We started with work package A, and that started in August and will commence by the end of December. And then all of the other ones are next year. So we have B and C that are starting in January, and then we have D and E the 2 months after that, which is going to be quite a lot by the time we get into sort of April, May. It's going to be quite busy. Okay, so I'm going to speak a little bit about how we are managing this project and how we decided how to manage this project. So we've got, you can see, I think, the arrows of inputs and outputs. So when I was thinking about how are we going to manage this project, like what's an appropriate methodology, and I'm not, you know, like I'm not a trained project manager. Okay, I've learned on the ground. So methodology is not like my big thing, but I'm interested in systems and how they work. So the inputs that we had were really what we got from the investor and what we thought would be the right thing to do. So we knew that we had to give monthly reporting, and we knew that we had to say what we'd done and what we'd learned. And we knew that we had to have predictable billing, because we'd already said how we were going to bill them and how much every month. And we knew we had to do timesheets because that was contractual. And we knew that we'd already agreed to like when the work packages would be delivered, so we had those dates, and that was something that we had to deal with. Then we also have these goals of, well, it actually has to be meaningful. It can't be a tick box exercise, because who benefits? It's probably even more harm than good to do that. We wanted to make sustainable impact, so obviously we just don't want to do something that then gathers dust and nobody ever sees the benefit of it. It wants to be something that contributes to ongoing benefits. And then it was really important that we have as much collaboration as needed with the FreeBSD project itself. And so what we decided we would do is to have a milestone-driven project methodology, which obviously with the work packages is what we needed, but also to have this close collaboration with the project. So I mentioned before we've got these bi-weekly steering calls for work package A, because it's specifically about technical debt and bugs and things. That was mainly with the source manager team. For the other work packages, it will be other teams. And we've got the foundation staff as well in there. We've chosen to go down the path of mixed resourcing. So we've got the source manager team actually doing some of this work as well. Then we've got Moin, who is one of our full-time staff who was recently moved over from being contract to full-time role with us. And then we've also engaged an analytics specialist called Bitergia, who essentially only really do open source project work, open source project health work. So, and then in terms of other processes that are new, internally I mentioned project accounting. So, just to give you a flavour, this is work package A. It's the only one that we're in flight with on this particular project. So, our approach was to collaborate with the source manager team and to jointly develop strategies. So, we approached the team and asked them, you know, this is broadly what we would like to do. Like, how would you suggest approaching it? So we worked with them to develop the strategy. One of the things that they asked for immediately was we just need to better understand that backlog of issues in Bugzilla. So we worked with Bitergia. We appointed Bitergia to help us with that. And then, as I mentioned, Source Manager really wanted to be able to understand the bug backlog, so that we've stood up an open source software project called Grimoire Lab, which is takes in the data from Bugzilla and allows you to query it and present it according to understand what you're doing with the bug backlog and particular characteristics of it and how you're managing it. And then we've created, essentially the Source Manager team has created a new bug triage and remediation process which is developing as we speak. In terms of achievement, working so closely with Source Manager has given us a good level of transparency at that level, and I know that when I was at EuroBSD Con, transparency was something that particularly the core team was asking for from the foundation, and I know the developers were asking for from core. So it's all over. Everyone wants more transparency. So this is one place where we're working towards having more. We've achieved having a project-directed strategy, which is really important. And then the new tooling is now available for understanding those issues. That's been customized for the FreeBSD project. And all the Source Manager team have had training on how to use that. Also because, I think I've said it. No, I didn't say it. We are hosting it on FreeBSD. So it's completely open source and customizable by us. And there's a community of users on that project as well for anything we may wish to do in the future. And also we were able to offer Moin's time and help on supporting the Source Manager team with that. Challenges, yes, we've definitely had some challenges. It was quite a rush to get the project started because the project started the day we signed the contract, and I think with hindsight, like we probably should have had a bit more breathing space, but it hasn't been great doing it like that, but it's been all right. It hasn't crashed. We didn't have formal processes for selecting a supplier when we selected Bitergia. So that was a little bit slower because we had to sort of spin up a quick process to help with that. Project accounting is a new muscle that we're having to create and train. And, the foundation is resource constrained, and so is the project. And, just asking people to give up more time to work on this stuff, people just don't always have it. But as always, people have been very generous with their time, so it's been very, very good. So let me just. Okay. So let me just say a little bit about Grimoire Lab. I won't go into this in too much detail, but we'll be following up with some more kind of information about this for anyone who's interested as we start to get to grips with it and the Source Manager team feels more confident with it. But we have some dashboards that are essentially showing, this one shows the backlog and whether it's going up or down, and things like backlog management index, which is like the what does it say? Efficiency and closing issues. So there are some ways of thinking about how you manage your backlog, and then you've got some other dashboards here about how long bugs have been open and things like that. So these are 5 dashboards that were requested and specified by Source Manager team that Bitergia created, and that has now been handed off to us on an open source platform. So they're going to be using them for things like bug triage sessions, community bug triage sessions, and creating guides on how to do bug triage and management for anyone to follow. So what's next? We have 2 more work packages. They're both due to start in January. One is Zero Trust builds, one is CI/CD automation. So because we had a little bit more lead time on these 2, we're actually starting before the project starts to plan up on what the scope will be and how we're going to approach it, so that we can start to think about it if we need to engage any contractors or any suppliers. And you can see that we've got various teams respectively for Zero Trust build and CI/CD. You may not have heard a huge amount about this to date. We do need to spin up a little bit more about the communication on this. It's understood that will help. We want better transparency. handing over of that work package A, which is due to end in December, to the source manager team, so they can own that and take that on. And then work packages D and E, which are the last two, and they start in, I think, February and March, or March and April. All right. Laptops. Oh, sorry. Laptops. So laptop usability is really only starting now. So I started picking up this project just a few weeks ago, to be honest with you. So it's very much everything's getting spun up at the same time, and I should have had that GIF with the plates, you know. The source of investment for this is the FreeBSD Foundation, that's investing $500,000, and Quantum Leap Research, which is investing $250,000. The actual whole project scope was estimated at $1 million, so we're a little short of everything that we wanted. So we think probably some of the scope that I show you will have to be de-scoped, or it'll just sort of happen, you know, along the way, depending on how the money goes. Our objective is to allow FreeBSD to run out of the box on a broad range, that's not very specific, of personal computing devices. And you'll see in a minute, but we are going to make a list of things. And then the output will cover Wi-Fi, audio, suspend and resume, graphics, Bluetooth, and other things, which is just a list of other bits and pieces that don't necessarily fall into a category. Or they have a category each, maybe. And the initial use case is broadly for developer users. So how did we get the investment? So we actually just received a cold email from QLR. And they just sent it to info@, and I think it was just like a really short email saying, "Hi, interested in laptops? Can we chat?" And so that's how that conversation got started. As mentioned, Quantum Leap Research has long-term plans that involve FreeBSD and laptops. And after some discussion, it sort of became clear that this would be a great opportunity for the foundation to accelerate that investment by adding additional funds into it. The roadmap is not really time-based like the other one was, and it's not really milestone-based per se, but it's much more functionality-based. So it's much more like product development than it is project management. Luckily, I've been a product manager as well, so that's fine. So what we were trying to solve for is obviously monthly reporting, because people want to know, hey, I gave you some money, what's happening? But actually, Quantum Leap Research, you know, because they will be a user of laptops, they are much more of a long-term partnership. So they are not necessarily just looking for this all to be delivered in like according to a certain time and according to a certain spec. They just want to know that it is being invested in and it is progressing over time. And I think they're interested in seeding a focus on laptops. So our goals are to have regular delivery of laptop functionality, which means not just working for 2 years and then, hey, we did this, what do you think? Which, you know, is a recipe for, you know, people to feel like they just had to wait a long time and weren't involved. We also wanted to have a high level of transparency to users and developers. And we also wanted to have high situational awareness of the FreeBSD user and developer needs. So we don't have the whole picture. Nobody has the whole picture. We want to do as much as we can to build that picture. Over time, we probably don't have all the information right now. And we also want to have good coordination, because there are so many different parts of FreeBSD that have to be looked at to get laptop usability, that you know, there are multiple technical work streams that need to be coordinated. So the decision there was to tackle this using, I hope I'm not going to traumatize anyone by mentioning Agile. It's got a small a, so it's less threatening. But we have, essentially we're going to do monthly iterations with our contractors just to say, can you deliver something that you can do with a laptop that you couldn't do before in a month, and just deliver a small thing every month from each or from several of the work streams. We're looking to have user stories as the I need to speed up. Primary work definitions. That just means that it has a usability focus or a user-centered focus. So we know why we're doing something, and we're not just testing that a functionality is now there, but that actually fits into the way that you want to use it. And then the other thing is to work in the open, and that means having a public roadmap. I'll talk a little bit about the laptop and desktop working group, and then have regular reporting. Okay. So I'll just skip through that one because it's already been mentioned, but I'll give you a moment just to absorb some of the candidate items, which is probably the slide that you've just been waiting this whole talk to look at, right? But here are some of the potential candidate items that will be included in this project. That's by agreement or by consultation to some degree. We don't want to necessarily say that we know everything about what's needed for laptops, but we want to make sure that as we're working the open and listening to the input that we're getting. So how far have we got? We have this roadmap, which it's in GitHub. It's not public yet, but we're working on it because not all of these are quite ready. But maybe in the next month or so, we'll be trying to get those to go live. Creation of a laptop and desktop working group. That's to start next month, so do get involved with that, and I'll put some details up in a minute. There are some things that we want to work in November that we've already identified, and we already have some contractors to work on that. So here's the details of the laptop and desktop working group. If you already know about the mailing list, there's the FreeBSD desktop working group, desktop mailing list, which you can certainly, if you join the mailing list, you'll know about when the first meeting is. And obviously we're still in the process of spinning this project up, but we'll be refining user stories, setting, I did use the capital A for Agile there. Agile working practices, communications and accounting to come. Hey, how many minutes for questions? 1? -3, oh dear. I thought I was going to be under time, so I was just, relaxing. Did anyone have a question? Okay. Ross? How am I going to collect the user stories? So user stories are being, when I say user stories, I'm not necessarily talking about like case studies of individual users out there and tell me about your story. User stories are, I'm describing in an agile management sense. So it's as a developer, I want to be able to connect to Wi-Fi using modern standards so that I can use my laptop. So that's the sort of structure of user stories. How we're collecting them is we're expanding them out of those kind of 5 or 6 areas that we know we need to cover. Having said that, they will be developing over time, and we'll be breaking those down, with advice and input from various quarters. Yeah. Any other questions? Oh, somebody had a hand up and it went away, but maybe it was the same question. Oh, hey. Did you have a question? So the question is, if there's people who are interested in doing things, who should they talk to? I would very much recommend coming to the working group. And do you mean paid or volunteers or paid? Paid. Oh, in that case, I would say you can speak with me or Ed. Is probably your best bet. Yeah. Cool. Do we have more time for questions, or is that kind of it? One more? Yeah. Are any of the drivers for neural processing units for machine learning? I do not know the answer to that. I'm thinking probably no, but I'm looking at Ed. So the answer was nothing specifically in scope, but we can look at it potentially. Okay. Perfect. Thank you.
All right, so we're going to break for lunch. So we'll be back here, I think, when's the next one? An hour, so 1:30. Thank you all. Folks, I think we're about ready to get started after lunch. So next up, this will be a very interesting topic on rescue kernels and direct dumpers in FreeBSD.
Thank you. So my name is Shrikanth. I work for the FreeBSD team in Juniper. I guess after reviewing all the presentations today, one thing that I noticed was I didn't have my bio slide on that. It's going to be my first presentation. Maybe next time I'll put a more elaborate one about the team in Juniper for FreeBSD. So I'll be giving a very brief overview of the rescue kernel and direct dumper in FreeBSD. I guess it's not overly technical, but yeah, it's going to, the objective was to engage the community on this topic. So this work was primarily done by Clara Systems for Juniper networks, and I guess the heavy lifting was done by Clara, and then there was some porting effort to make it work within the Junos build environment and deployed for the Juniper boxes. So I'll give a overview and the what and why this solution was required for us. So some of the boxes that we have no problem with provisioning, any amount of storage partitions or so on. So when you typically want to save a crash dump, you have a FreeBSD swap partition created, and at the point of crash, you just capture the state of the system memory, and it is redirected or captured onto the dump tab, which is mapped to the swap. And after reboot, the save core script should save the crash dump and save it to the war crash. But that requires a dedicated swap partition, and that is what is a little challenging when you go to low-end boxes. So for our low-end boxes, we have some gear, some EX gear that looks like this when you do the Gpart show. You have an 8 gig storage, and 1.5 gigs is given to the OM volume, which is an administration volume. It has a very small recovery snapshot and some essential files to recover the Junos volume in case that goes bad. And rest of it is given to the Junos partition. Now, there is no scope here to add or create a separate swap partition here. So in case of panic, we still need to be able to collect the crash dump, and preferably on the Junos volume. That is why we need an alternative solution. And even for some of our virtualized platforms, we have similar challenges where most of the provisioning is done with respect to the OM volume and the Junos volume, and a very small, negligible thing is given for the swap. So again, capturing crash dumps on such a box becomes a challenge. So this is the why we needed that. So that's where the rescue kernel and direct dumper came into the picture. The key requirements or key points for the rescue kernel and direct dumper are when the main kernel panics, you want to automatically boot a small but dedicated rescue kernel, which has very minimum things to do. That it runs out of the reserved region in RAM, and it should be able to quickly repair and mount the local file system. Then once it makes sure that the file system is okay, it proceeds to capture the contents of the RAM from the main kernel directly to a file. It does not require any reservation of the disk space. Now, the downside for that with the current implementation is the integration complexity. The changes are such that you want to be able to compile, you're compiling the rescue kernel and the small root file system directly with the main kernel. And that is the integration complexity with the current approach. It allows you to embed a small root file system, which means that it allows you with a minimal script and some interactive capabilities. So a typical script could look like this, where you could do a quick file system check, mount the volume. In our case, it is the Junos volume, and do a DD just to capture the crash dump, and then proceed to reboot the box. These are some of the build aspects of it. We want to keep the kernel small, so that's why we exclude a lot of the key options like SMP, witness, syskernel description, and so on. So that is why it is like so lightweight and very minimal in its objectives. Embedding logic in the kern post-muck is where the embedding magic happens. You pass the rescue kernel image and the small root file system, the embedfs, and use the MFS image option to build a rescue.o binary, which is then linked into the main kernel. Now, where this would show up is when you run the objdump on your main kernel, you would see a new section that got added, which is the MFS, and that would be proportional to the size of your rescue kernel in the embedfs. So next, I'm going to talk about like what are the main tasks for the rescue kernel versus the main kernel versus the rescue kernel. So the main kernel, when it boots, it has to initialize a staging area for the rescue kernel. It is done via a sysinit, and it would do the essential metadata stashing, loader tunables, and the EFI memory map. Then it proceeds to copy the rescue kernel to the staging area. Any tunables that you would like to pass to the rescue kernel would be prefixed with the debug.rescue. That's till the point where the main kernel processes them and then sets it up for the rescue kernel, where the rescue prefix will be dropped. And then finally register the rescue dumper via the dumper insert. So this time around, when you check what is your dump def, it will show up as rescue rather than the standard default one. CPU mini dumps is the path where the fork would happen. So it would check if you have the do rescue mini dump global configured or like set, and that's where it'll take the path to boot the rescue kernel. There's trampoline logic both for ARM64 and AMD64 to jump to the rescue kernel. I think the approaches used by both are dependent on the architecture. So it's a little different for AMD64 versus the ARM64. The rescue kernel booting is pretty standard. It doesn't have anything fancy. It boots like a normal kernel boot. It detects probes and attaches like the storage devices maybe, and it has a dev dumper, access to a dev dumper, which is where the support for capturing the host kernel's RAM will come from. The dev dumper driver will provide the dopen and dread calls, support for the dread calls. So dopen will map the segments that are needed from the host kernel that need to get included in the mini dump. And when you DD from the dev dumper to the Junos volume or like whichever partition you're trying to copy, it would invoke the dread from underneath. So these are the differences between the main kernel versus the rescue kernel. And I think the next two slides I'm just highlighting the difference in the code paths. So if you look at this, like the initial set of calls are the same, but when you arrive at like CPU mini dumps, that's when you decide whether you want to do a rescue mini dump or the standard approach. Yes, with that, I just wanted to show a quick demo. This is not from a stock FreeBSD for us. It is from our EX box. I have a DDB built into my kernel, so I can drop to the debugger with a key sequence and simulate a panic. So we see here has the sprint where the main kernel will hand off to the rescue kernel, and then you see immediately the rescue kernel booting. So this would be very quick. It doesn't, as I said, it doesn't do a lot of other probe and attach. Its job would be to do the quick file system check and assess how much of dump it needs to capture. So once that is done, it would directly write to the var crash on the host or the partition which was mounted for the original kernel and proceed to reboot. I guess that's the overview of the rescue kernel and the direct dumper. Now, in terms of upstreaming and what are the further roadmap, this review has been submitted by Justin Hivitz. He's part of my team. There are a lot of interesting discussions on that review already as of writing or as of presenting this today. So some of the improvements are like, we changed the approach from embedding the rescue kernel at build time to preferentially loading the rescue kernel into a reserved memory via some kind of a syscall interface. And possible additional use cases are if someone would like to do dump to a encrypted storage, then this could provide like a framework to extend. You could extend that framework to that use case. Also, maybe evaluate this to boot an alternate kernel. I guess that's that, and this is just to show what's the bloat in the kernel when I compile it with and without the rescue. So my production kernel was 7.9 megs, and with my rescue kernel plus the embedded FS, it bloated by around like 16 megs, which is what shows up in the MFS section part of the main kernel. Yes, yep, open to questions.
Beautiful face and my dulcet voice. I don't think either of those are true. One of the problems I ran into with ARM is that the interrupt processor has a misdesign. Once you program it once, you can't reprogram it without doing a hard reset, and you can't do a hard reset and do transfer to a new kernel in a controlled way. So the old Linux kernel passes to the new Linux kernel or to the new FreeBSD kernel with my stuff the state of the interrupt controller. Is that something that you guys are doing now, or are you running on hardware where that's needed, or how do you handle that?
We haven't definitely evaluated that. This was for a crash dump. I think we didn't really care about the piece that you're talking about, so that's why it's not on our roadmap, I guess. But yeah.
You're using interrupts, because I know one of the things in the patch is it iterates all the interrupt sources to shut them down before booting into the, that's one of the FDEFs in Kernel.c, I think, is to shut all the I sources down before we boot the new kernel. So I think you just haven't tripped over that particular interrupt controller on ARM yet, is my guess. Although if you shut them all down, maybe well, it's the one, you have that one block of memory where the thing is mapped, and that's what you can't move. There's a register that points to like a table in memory, I think, for the ARM GIC, and you can't, you can write once, you don't get to change it. Anyway, if you haven't hit it yet, you will probably hit it.
One thing you had asked about was other use cases, and some of the ones that we've thought about are obviously a more performant version of NetDump, rather than having to do pulled I/O on the NIC and so on, if you're booting this rescue kernel, you can bring up the full network stack and be able to send the crash dump to a remote machine much faster than you could in the existing net dump stuff, and probably with a lot less setup and so on. But another use case that I've personally been interested in is being able to do a crash dump directly to a ZFS file system, right? Because once you're booted in this rescue kernel, you can have a working kernel that can import a ZFS pool, and like in your case where you're writing to UFS, you could again be able to take the crash dump to ZFS without, you know, especially on large memory systems where we've seen systems with as much as 6 terabytes of RAM in them now. You know, you're not going to have that much swap laying around to be able to take a crash dump of, you know, a huge amount of memory. And so being able to put that directly on a file system, again, is much nicer than the doesn't actually work yet version of crash dump to RAID Z that ZFS has some support for, where you kind of pre-allocate all the space ahead of time so that you could just have your rescue kernel or your regular crash dump try to write to those offsets or something. Whereas, you know, having a fully working file system gives you a lot more options, or a fully working kernel means you have a lot more options for, like you said, encryption, compression, and then sending it to other places or file systems or the network or whatever.
Thanks, Tom. Yeah, I guess the review page is also interesting. I mean, several good comments already, I guess. So it's worth the read. I guess that's it. Thank you.
So I guess we have a break for a bit. Well, I was going to say reminder, if you wanted to sign up for a WIP, go ahead and sign up. But actually, my WIP board is full. So if you wanted to do a WIP, I think your opportunity to sign up is over. So we'll be doing that later today. So I think we have a break for a bit. I'll check when we come back. I left my phone back there. So just one, or my own, one minor update. We're going to tweak the schedule a little bit. We'll start the next talk at 2:20, which is a little under a half hour, and it'll give me a few more minutes for whips. I can be a little nicer to people if they go over. So see you back then. Okay, folks, if we can find our way back to our seats. Getting ready for our last normal talk of the day. So Alan Summers is here, and he's going to talk about his latest project that he's working on. So I'm going to turn it over to Alan.
Hello. How's the mic? Are we intimate enough? All right. So, hi, I'm Alan Summers. I live in Longmont, Colorado. I've been working on FreeBSD since 2011, ever since Justin Gibbs hired me. Hi, Justin. And for the last 5 years, I've been working for a company called Axcient, which does a backup and disaster recovery, a cloud-based program. And I'm going to talk to you about how we use FreeBSD, what advantages it gives us, what it means to us, and what problems it has. So, first, about our company. We sell a variety of products, but they all can basically be generalized as backup and disaster recovery. A medium-sized business has 100 laptops. They all back up to our cloud, and they would store when they want. Remember those hurricanes that hit Florida a couple of weeks ago? Some of our Florida-based customers were able to restore their servers as soon as the hurricanes hit, and based on their backups, we restored them into a virtualized cloud server, so their businesses had no interruption. All of these products are various different backup products, store all of their data on FreeBSD. Once upon a time, we used Oracle Solaris 11 to do this. It's okay. I'm in therapy. But we converted everything to FreeBSD storage about 5 years ago. How do we actually store it? Here's the simplified version of our software stack. You're probably familiar with all of these components. We use both NVMe disks and SAS. We multipath our SAS for high availability. Most of our servers have a lot of disks, like 100 SAS disks, 100 to 400 SAS disks. We encrypt everything, both at the customer level, but also with Jelly at the disk level. There are regulatory requirements for storing things like health data, and using full disk encryption makes it very easy to satisfy those regulatory requirements. So we encrypt everything, usually twice. The data is all stored in ZFS, and I am sure you all know plenty about ZFS, so I'm not going to talk about that. We serve some of it over NFS for some products, some of it over iSCSI for some products. We use a little bit of Fuse, not terribly interesting ways. If you've noticed that I've committed a lot of stuff related to Fuse, that's actually mostly not related to work. When we're not using NFS or iSCSI, most of our products actually run directly on the storage. I'm not going to get into all the proprietary apps we have, except for one. I'm saving that one for the end. Other features that are important to us, and we're glad that FreeBSD provides them, includes the PF firewall, the audit security framework, lag for LACP that gives us redundant networking, as well as the LLDP daemon from ports. I'm very grateful somebody introduced that to me. It makes it very easy to debug LACP problems. We use VLANs. We use DevD. That's especially useful in combination with gmultipath. We use ZFSD to automatically prepare our ZFS pools. We use the SES driver to both determine the state of our SAS hard disks, as well as to illuminate the little error light that the technician can use to find the broken ones. We use jails. We use them for both transitory and persistent purposes. Currently using IOCage to manage the persistent ones. We do monitoring with Zabbix and Prometheus, configuration management with SALT, DNS. We use zREPL to replicate ZFS datasets over long distances. These are all imports. LDAP for user accounts and NSCD for caching of names. Believe it or not, we still use INetD. That was invented back in the days when it was too expensive to have a single server doing nothing but listening to a socket, but it's still useful in this era. To build our images, I think Ian yesterday at Medics was talking about building full images that you can write to a hard drive. That's actually not what we choose to do, because upgrading in a case like that, even when you only want to change a userland component, does require a reboot. Because we're concerned more about downtime, we use FreeBSD update build and FreeBSD rust date to install all of our updates, just like a desktop user would use, except we have to build everything ourselves. And I want to mention that just a couple of months ago, FreeBSD rust date appeared in ports. It's like 100 times faster than FreeBSD update. It's great. Also, as Ian from Bedix mentioned, we use Prometheus for monitoring, for real-time monitoring of all of our performance and error conditions. It's easily available in ports, and there's quite a few off-the-shelf exporters for it, all in ports. You can get, CPU load, uptime, network throughput, sysctls are all in the base system. It's also very easy to write your own Prometheus exporters. So we've done that. We've written our own exporters to get data from NFS, from iSCSI, from libzfs, ztop, and a couple of proprietary things too. And several of those are now in the ports tree for everyone to use. Working at a storage company, disk failures are an everyday occurrence. So we've had to get really good at automating our disk replacement process. Basically, it goes like this. We start with a healthy pool, and then if a disk generates too many I/O errors, or slows down, or disappears entirely, ZFSD will automatically fault it. Then Prometheus will pick up the fault condition and alert us engineers. Or we also install SmartMon tools from ports. And once a day, we run SmartMon's periodic job, which checks every disk's reliability info. Any disk that has a predicted failure will generate an email that sends to us engineers. And then if we agree with the prediction, we run a script on the server to fault the disk. This is the only real manual part of the process. On the server, we run zinject. It's actually a Python script that uses libzfs, but it does the same thing as zinject does. And turn on the fault LEDs in SES. And it also generates a JIRA ticket for the technician to read. As soon as the disk is faulted, ZFSD also picks it up and activates a hot spare. So ZFS begins resilvering a hot spare right away. So we minimize the amount of time we have with reduced redundancy. The technician usually arrives within a day or two and replaces the originally failed disk. DevD observes that problem and calls a custom script of ours which writes a new G multipath label, and then on top of that, a new Jelly encryption label. As soon as the Jelly device appears, ZFSD picks that up and replaces the originally failed disk with a new one, starts resilvering again, oftentimes even before the hot spare has finished resilvering. As soon as the replacement disk is healthy, ZFSD ejects the hot spare, and we're back to our original healthy pool. And of all these components, the only part that's closed source is that custom script that runs zinject. Everything else can be set up on any FreeBSD system. Oh, and the G multipath label, but most people don't need G multipath. So now I want to give you an example of how FreeBSD let us update an old legacy application. I mentioned that we were running on Solaris 11. One of the applications we had on Solaris 11 hadn't been updated very much since 2010 or so. It had a number of problems. In addition to being built for Solaris, it required an old version of OpenSSL, an obsolete version, and it statically linked to it. It also needed an obsolete version of PostgreSQL client, and it also statically linked to that. Even worse, it couldn't use the vanilla PostgreSQL client. It had a custom patch in there just to change the SIG pipe handling. And it could only use TLS version 1.0. I'm hearing laughs. Not 1.0 later, it was hard-coded to use TLS 1.0, which had known security vulnerabilities at this point. So how do we port this application, and how do we update it? It was remarkably easy thanks to jails, ports, and Git. First of all, we had to get a PostgreSQL client that could build and that could work with this program. But the ports history is all in Git, and ports is all a source-based package system, so we could easily pull the old PostgreSQL client out of Git. It didn't build on what was in current FreeBSD 12, but that's no problem. We also didn't have OpenSSL 0.9.8 in FreeBSD 12. But those things both worked in FreeBSD 9, so jails to the rescue. IOCage made it easy to install a FreeBSD jail running FreeBSD 9. And once we had that, we have the right ancient version of OpenSSL, and PostgreSQL can build again. So we built the entire application in FreeBSD 9 and did all the miscellaneous little fixes you need whenever you port to an operating system. Now, having a working program, we could get rid of that pesky custom SIG pipe patch, because FreeBSD supports the SO no SIG pipe socket option, which does just what we want. So we teach the main binary how to use no SIG pipe, and then we can eliminate the PostgreSQL patch, and once again run with vanilla PostgreSQL. Then we needed to get a currently supported version of PostgreSQL and OpenSSL. So we just kind of walked up the version tree, updating one then the other, and updating the jail until we got to 11. Everything was still supported then, so we were able to deploy on FreeBSD 11. FreeBSD 11 jails, that is, on a FreeBSD 12 host. So between jails, ports, and Git, we were able to take a big problem and make it into a lot of little small problems, greatly easing the maintenance of this legacy application. Next problem. We had a new business requirement. Some customers want to restore their data using FTP. FTP over TLS for security. That's fine, but all of our servers are multi-tenant. Lots of customers may host their data on a single server, and we don't want any cross-tenant access. How do we ensure that one customer using an FTP restore cannot get another's data? The most obvious way to do that is just to rely on access validation all within the server process. That's what most software does. Custom web servers or every single off-the-shelf FTP server that there is already, every single one in ports does this. But the problem is that the attack surface is far too large. If there's an attacker, the potential attack surface is the entire program. A bug anywhere in the program might potentially enable an attacker to get hold of data they shouldn't be able to access. And we can't ensure that there isn't a bug anywhere in the program, especially because we're not even writing the FTP server from scratch. We're going to choose one off the shelf. So the next obvious solution is to use this wonderful feature I've already described called jails. Can we jail the server process? Jail it to within just the home directory of one user. That would neatly prevent any cross-tenant access, but it comes with another problem. There would be way too many jails, way too many customers. We can't statically create one jail for every customer. That would be too many jails for one server. So we have to do them dynamically. Create a new jail every time a new customer connects and tear it down when they're done. That would require lots of configuration. It would be very complicated. Might solve the security problem, but it would probably bring in new bugs. But there's a third option, to use Capsicum. Let's see if show of hands. How many people are familiar with the basic principle of Capsicum? Okay, that's most of us. To summarize it for the rest of you, Capsicum is awesome. It's basically a way to jail a single process, to reduce the privileges that one process has so that it has access to no global namespaces, no global file system, no global IP address space, no global sysctls, no nothing. Instead, you can delegate to that process only the capabilities it needs when it starts, and it can never gain capabilities after that. And yet, what really makes Capsicum awesome is that all of this is done with zero configuration on the part of the system administrator. It's not like SE Linux or like mandatory access control, where you're essentially writing a firewall for your file system. Instead, all of the logic is embedded by the programmer into the application, and it reduces privileges automatically with no input from the system administrator. That's what we chose. It's configuration free. Once you program Capsicum into an application, there's nothing the system administrator needs to do. And all that privilege isolation is enforced in the kernel, and it's the same for every process. So the attack surface is much smaller than the entire server application. And getting better, as I believe Alice just talked about regarding Synactive's at it. Thank you for that. So how do you capsicumize an FTP server? First of all, FTP is kind of weird. It's actually older than TCP, and so the protocol does some unusual things, like it creates multiple sockets, and it creates them in a bidirectional fashion. So the first thing we have to do is just disable active FTP mode. That's okay, because almost every client supports the newer passive mode anyway, because it works better with firewalls. So our server only does passive mode. The second thing that you have to do when capsicumizing any application is to do all your initialization a lot earlier. Allocation, opening files, especially in our case, opening TLS certificates, all that needs to be done earlier. That's easy. The third task is usually the most involved for any application. You can never use the open syscall. Instead, you have to use open at. That works based on using an existing directory file scripter to open a file in a child directory of the initial descriptor. And that's, that descriptor is also known in Capsicum speak as a capability. And that's how Capsicum can keep access to a subset of your entire file system. You open the directory when the program initializes, and then when you enter Capsicum mode, you drop the privilege to the entire rest of the file system, but retain that capability. In our case, using OpenAT was actually straightforward. There were no hard problems to convert the file server to use that. The fourth obvious change we have to make is that we have to fork a separate process for every connection, because Capsicum applies at the level of the entire process. So if you want a server that serves multiple users, they've each got to have their own process. This is not too weird. It's what Apache has long done for serving websites. Even though it's not perhaps the most performant option for web servers these days, it's easy to fork a new process for every user. Fifth, and this one is less obvious, it is not sufficient to fork a new process because KQ is never inherited on fork, and our listening process uses KQ. So we actually need to exec a new executable just so we can open a new KQ. We exec after we fork. Next, we need to use Casper in order to make bind work. I said that a capsicumized process has no access to global namespaces. Well, that's the ideal, but occasionally you need to do things anyway. In an FTP server, for example, you typically can only use certain ports for the data connection. Those are configured by the system administrator. But bind is a syscall that uses a global namespace. So how can you call that from Capsicum? That works by using libcasper, which was written by our colleague Pavel, who's back there somewhere. Hi, Pavel, wherever you are. There he is. Casper works by creating a separate child process right when your Capsicum process starts, but before it enters Capsicum mode. The child process itself never enters capability mode, and it communicates with the parent over a Unix domain socket using a well-defined interface. So the child process has permission to do things like, in this case, call bind. When the parent process needs to bind a socket, it instantiates a socket and then passes the socket over the Unix domain socket to Casper. Casper binds it and then passes it back. The interface that goes over that Unix domain socket is very small and is easy to audit, so that keeps the attack surface small. It gives you the security advantages of Capsicum while allowing you to use the occasional global namespace like bind. Finally, I mentioned we have to fork for every connection. The FTP server we used was originally multi-threaded, but since we're forking all the time anyway, we switched it to work in single-threaded mode. Both the listening process works in single-threading mode, and now the worker processes are single-threaded too, because we've got a lot of parallel connections, so why not? The FTP server we chose to use is called libunftp. It was written by Bolcom, which is an e-commerce company in the Netherlands, and it's open source. You may be asking why we didn't use the one that's built into our operating system already. That's because it doesn't have TLS support. And it was easier to go out and use this third-party FTP server that already had TLS support. It's on GitHub. You can download it. Our specific program called capbind is actually closed source. But the binary only contains boring code. It's got stuff like our details for user authentication. All of the interesting changes that I've talked about here are part of the library. And in fact, the library includes a fully functional FTP server as an example that you can download if you want to make an application based on it for your needs. And finally, I'd like to mention the things that FreeBSD doesn't have that we do wish it would have, and some of which maybe we could do someday if we have the time. Top of my wish list is probably to integrate SES with ZFSD. SES is really important to us as a way for the engineers to communicate to the technicians, but right now we've got we have to use a separate set of scripts just to activate that disk's fault LED. ZFSD is really the right place to do that because it knows which disks need replacing at any given time. If we could integrate those, that would improve our workflow and it'd help everybody else, because as far as I know, everybody who uses SES right now has to re-implement the same stuff over and over. Another great feature that we could have, though it might be a lot of work, would be integrating multipath directly into CAM. CAM actually has all the information it needs to know which two disks belong to the same path. That stuff comes through SES, and CAM has visibility into SES. It just wasn't written with multipathing in mind, which is why somebody had to do it in Geom. The Geom module works well enough, but using Geom requires you to manually write a label to every disk. CAM, if it were aware of multipathing, could do that automatically. No labels required. Another great feature would be ZFS encryption. Though people are already using it, it's kind of notorious for bugs, and we've already heard mention of that during this conference. We've experimented with it, but we suffered some data corruption bugs, so we abandoned it and went back to Jelly. If we could use ZFS crypto, that would be great because it's fundamentally faster than Jelly. Jelly encrypts data after the parity has been calculated, but ZFS encrypts it before the parity has been calculated. So ZFS has a lot less work to do. Clustered storage is another pain point for us and a lot of users. We've experimented, but all of the clustered storage options that are available in, and as far as we know, outside of ports, are just too complicated for the small subset of our business that could actually benefit for them. So we're not actually using any at this point. MooseFS or Ceph seem the likeliest contenders. It'd be great if we could improve that story. KTLS is another great feature. That's one that only appeared in FreeBSD 13.1, I think, but it's pretty awesome. It would be great when paired with ZFS receive. And it's also great for things like file servers, like the FTP server that I mentioned, when you pair it with SendFile. So far, our need hasn't been great enough that we've done that ourselves. We might someday. It would be a great feature to have. Jelly performance issues. We're heavy users of Jelly, and one problem it has is that by default, it creates a thread pool for each disk. A thread pool with as many threads as you have CPUs. That's great if you have a laptop with a fast NVMe disk, but if you have 400 disks and 24 CPUs, 400 times 24 is an awful lot of threads. Even if you tune it down to just one thread per disk, that's still too many. Having a global thread pool instead of a per disk thread pool should, in theory, be a lot faster. I've actually prototyped that, but in some cases it ends up being slower than the status quo, and I've never had time to solve all those problems. It'd be great if we could do it someday. The final problem I want to mention is that K-event still, after all these years, doesn't quite work very well in Go. If you try to use K-event in a multi-threaded Go program, it ends up creating multiple K-events and then accessing each one of those from every thread. This creates tons of in-kernel lock contention, and it's actually one of the biggest CPU consumers in our entire product, embarrassingly. Even after we've tuned it down, it's still kind of bad. I lack the Go skills to fix it myself. It'd be great if somebody did, sometimes. Okay, that's all I have tonight. I hope I've given you some idea of what value FreeBSD can bring to a business like ours, and what advantages it gives us that we can't get anywhere else, and what we get from it. I'll also, I hope I didn't underemphasize what we give back to. We don't want to carry a whole stack of changes in our private tree. We're not selling FreeBSD, we're using it. So we try to contribute back every patch as soon as we can. And if there's some feature I've talked about that you're more interested in, we probably could release a source if there's interest in it. For example, getting Prometheus data from ZTop. Are there any questions? Pavel.
So you, so you did mention that in the disk replacement process, you monitor if the disk is faulty, but also if the disk is slowing down. So I would like to, if you could elaborate how you monitor if the disk is getting slower, because that's a big problem.
Pavel asked how we monitor if a disk is too slow. Yeah, yes, okay. Your accent is sonorant, Pavel. This is a new feature we added to ZFSD. ZFS, or is it Geom? ZFS will emit an event to user space if a disk takes more than a certain amount of time, well, really a Geom provider takes more than a certain amount of time to complete an operation. And so there's now a rule in ZFSD that will fault any disk that gets too many of these events within a certain time frame, 10 events per minute or something like that. And it's tunable based on VDEV properties. You may also want to talk to Alan Jude, who's working on another feature for detecting slow disks. We have more questions? Good question. The question is, before we used Capsicum with FTPD, did we try the Jails approach, and at what point did it stop scaling? Oh, static Jails. No, we didn't. We never even tried that, because we know we have too many consumers. With FTP, we went straight to Capsicum. I will say with another product, we did use the Jails approach, but we used the dynamic Jails, not static Jails. We create them on each connection. And that's working okay right now. It's just a lot more code. I prefer the Capsicum approach myself. Michael Dexter. That's the way we fault a disk which otherwise ZFS thinks is okay. ZInject is intended as a testing tool that you can use to fault a pool to see how ZFS handles that. But if smart CTL predicts that a disk is going to fail, or if the engineer observes that it's too slow or otherwise not working, but in the way that ZFSD doesn't get, we fault it itself so that it doesn't slow down the entire pool. That's what ZInject does. Any more?
So in your use of Jelly, are you just encrypting the file system, or are you actually encrypting each file?
We use Jelly for full disk encryption. So we're encrypting at the disk level beneath the file system. Any more? John.
So for the Jelly thread pool thing, we definitely should fix that. I know that there's an open PR from some folks. There's like an AMD Systems or something where they're using ASNI and they have lots of providers and they do not like having all the threads. So definitely, I think even if it's in some cases a little worse, it really should not be umpteen bazillion threads. So a global thread pool definitely makes sense. My other comment is I can now appreciate all the various things you work on because I can kind of see how they're stitched together because like many of the things you work on is a wide variety of things across the tree. So it's very interesting to see how they all glue together.
Thank you, John. Pavel again. Pavel asked if AES-NI can do direct dispatch, which means that the data never needs to get mapped into the memory. It goes directly from user space to the disk. Oh, okay, I mistook. Geom direct dispatch is a different feature then.
In particular, with an open crypto session, there's a flag you can check to see if your session is async versus sync. And if your session is async, if you have some PCI coprocessor that's going to you'll queue request off to it, it's going to demade and send you an interrupt back. That you can't do in G up and G down because you'll block I/O in the system. But if you're using a synchronous, accelerated software, you could just do that synchronously. I think is what Pavel's suggesting. So when you're getting ready to dispatch Bio and Jelly, you can look to see based on what kind of crypto session I have the flag of is it synchronous or async. I can decide, do I just call it or do I actually use it's even a flag on crypto invoke, right? No, but I guess instead of punting to a K thread, you just directly crypto dispatch directly inside G up and G down. Does that make sense?
John, it's been a couple of years since I looked at that, and my memory is a little rusty. I cannot remember if there's a reason why that was not a possibility.
It's not with the PCI case, because then when you have a PCI coprocessor, you're going to have to sleep with the interrupt. You can't do that in G up and G down, but not with ASCII, because you know you're just going to run the program.
Right. We don't have a PCI coprocessor, but maybe the necessity of supporting such devices limits the API?
You can check a flag on the OCF session. So OCF will tell you if your session, when you call crypto new session and you get back your session pointer, there's a flag that tells you, is my session async or sync? So you could do a dynamic decision inside of Jelly. If I'm async, then I dispatch to the worker thread. If I'm sync, I don't. I just call crypto dispatch direct and I synchronously wait for it to complete and run within the G up and G down thread the entire time. I think that's a problem. That's actually probably a sensible thing to do if we don't for it.
Okay. Action item for the future. Okay. Any other questions? Okay. I think we're done.
Thank you, Alan. All right. So for our next session, we're going to do our WIP lightning talk session. So I have the whiteboard up here. If your name is on the whiteboard, I need you to queue up over here in order. So come on, guys. I think it's all guys who signed up this time. If your name is on here, let's line up. So you have 5 minutes. I have a buzzer on my phone. So when you start talking, I'm going to start the timer. And if you go too long, here, let's see. Yeah, it's not working too well, but you will see it if it's working. So my suggestion is when you go, make sure and introduce yourself as part of before you end your topic, and then go. And as soon as you start, the timer starts. So You don't have XR and R just memorized? I have a little start projector and stop projector, bin sh script, because I can't remember it either. All right, we're going to spend a few minutes. He may not need a dongle. He's got HDMI over here. Yeah, it's back. I waited 10 years between Macs so that I kept an HDMI port. That's how I solved that problem. I also kept those. All right. Okay, so Adrian's first on deck is Max. There you go.
Hi, I'm Adrian. I've been away for a while, but now I'm back to do more random Wi-Fi stuff. So if you've been looking at what's been going on over the last few years, Bjorn's been working on Linux KPI driver porting, and that seems to be going okay. The challenge, though, as he and others have discovered, is if we want to actually get Wi-Fi 11AX and 6 gig and all the new funky features, that porting the driver is not enough. We actually have to go work on the stack some more, much to people's annoyance. And the stack has not aged well, so I need to do a bunch of cleanup. A bunch of us have to do a bunch of cleanup there. The order of operations for why we have to care about this is at the bottom. If you want, if you want 6 gig mandates WPA3. WPA3 mandates a new authentication mechanism, mandates encrypted management frames. Encrypted management frames mandates a bunch of new encryption types, and a bunch of new data path handling, and all that plumbing has to happen for every chip except Broadcom. So if you want to use it for Intel, you have to do all this plumbing. Broadcom's the only chip that fully offloads everything and pretends to be Ethernet. That's a different story today. If you want to do some of the later encryption types that use larger crypto keys like 256 and 384-bit, if some offices are actually starting to mandate that for corporate 11x deployments, then you need to update your stack to include the larger crypto key sizes, which our stack almost but not quite can do without some changes. And as Bjorn and others found, our driver interface requires a whole bunch of cleanup around rate control for working with 11AAC and 11AX and a bit of 11N, and a whole bunch of stuff around how we actually represent channels, because all of that stuff is 25 years old now, and a whole bunch of cleanup. So I've been talking to a few people about what to do about this. People were kind of hesitant to really put the FreeBSD 15 in the blender while 14 was still sort of the stable was still being actively merged back into. But since I think 14's life cycle is sort of okay now, my proposal is we just sort of draw a line in the sand and we say, okay, let's run fast on this on 15 and actually get all the cleanups and API breakages that we need to get done, just get that done in head and not try to make any of this new stuff work on 14 and just leave 14 in maintenance mode like it should be in stable. Don't stop doing the Linux driver work, because it's probably a good idea to continue doing that work and get people on board with porting those drivers and learning how 802.11 works. All that work is actually really useful. But again, as Bjorn and others have found out, there's a big gap between porting the driver and getting the driver up and having it actually speak Wi-Fi. OpenBSD has gone and ported a bunch of drivers native from Linux to OpenBSD and running them natively. They don't bother with a Linux KPI layer. So they're actually further ahead on 11AC and 11AX than us, but their drivers run on BSD. So there's actually someone right now, I think it was Tom, doing a port of the IWX driver from OpenBSD into FreeBSD head for us to have as a test driver, just to use to finish off whatever bits are left over on 11AC. And there's a bunch of figuring out how we land code, because there's so much that needs to be updated. If we just get it all done, it's probably like a couple of 100,000 lines of diff just for net 802.11. Trying to merge all of that at the end of 15 isn't going to be that great. But to other people's comments, continuously breaking things in head, potentially not the best way to tackle it. So we've got to find some middle ground where we checkpoint certain features, we get them into the tree, we get them tested and adopted, even if it's not hitting everything we need for 11AX, at least we're heading in the right direction. And I'm hoping that with an IWX driver port and some Linux KPI improvements, stability improvements, and some general stack cleanup, even if we don't get 11AX completely going in the 15 timeframe, we won't be that far off. And what was the final thing I wanted to say? If anyone's actually interested in tackling more of the driver stuff, let me know, because I'd rather focus on the stack rather than having to also port all the drivers. I do driver work at work. I don't want to keep doing driver work at home. Like, it's fun, but it's only so much fun. I'd rather focus on the Net0211 stack and getting WPA3 going, because that's a lot of lifting. Any questions? I don't need laptops and I don't need hardware. I swear to God. Okay? So don't offer me anything. I've got it all. I've literally got it all.
All right, thank you, Adrian. All right. Next up is Max. There you go.
Hey everyone, thanks. My name is Maxim. I'm a long-time FreeBSD developer. I started with sports in like early 2000s and moved up a little bit to the food chain. So right now I'm most of my day job I'm managing my company, which I started with few guys a few years ago. Well, more like 15 now. But anyway, we use FreeBSD exclusively for our software. We have around 300 systems all over the place, running different versions from, I guess, 11 probably to 13. Yeah, once in a while we hit some bugs. So we had to deal with, like everyone probably in this room, with some failed asserts or some panics, which happens in some production system, and all you have is just a message. So I was looking at some of the curious panics we got a few weeks ago. Well, no, it's more like it's going like recurring kind of panic, which happened. Oops, what was that? Okay, anyway, I'll continue with my. Yeah, it is. But yeah, we deal with panics once in a while, and this one was, I believe, caused by some. I can unplug and replug and see. By some stray packet hitting some of the NAT handling. Oh yeah, it came back. It came back. But anyway, story is that we have two assert messages in two slightly different places in the function with the same message. So we got panic and we was like, oh, is it this or this is this? Or because there is no really information, just the message. So I was curious how we can add, maybe record also the number of line and the function name as well. And I just used some of the code that I used in my other project called RTP proxy. And what it does, it basically allocates read-only structure, which captures all those three parameters, essentially, two strings and one number. And if you don't use it, it will just be optimized out. If you use it, it's stored in read-only segment. And then if panic happens, we just dump it. And it's kind of makes things a little bit more debuggable. So as you can see, there is this stuff is new. So if I panic, this just test panic I inserted. You see this is the file, line number, and the rest panic is as usually follows. But this would make it more debuggable, and we have around the only downside, I guess, is this will create quite visible increase in the size if you enable asserts. So around 17, I think 17,000 locations in the kernel code with some kind of assert for the generic, or 25K for the lint. But anyway, it's in the PR, and I think if somebody can review it, would be nice. If you don't have like witness or any of that, like. Like if you don't have assertion, assert, or if asserts are disabled, then you don't have information recorded for that. Yeah, yeah. Well, yeah, but maybe default should probably be yes if. Mhm. Okay, that makes sense. Yeah. Yeah, if you have access to everything, but if it's something that you only have. I mean, it could be in like include file. You know, it's very difficult sometimes. Yeah, or maybe if you have direct panic call. So, for example, your driver in some kind of. Yeah, I guess you want some. Okay, yeah. I said that it's like. Yeah. Well, the fact that it's useful is actually few of the, for example, VFS has their own wrappers on those macros, which actually includes the line number. So this is basically just make it more generic and maybe optional, but kind of by default. I guess I'm right out, so thank you.
No, you're all good, Max. All right, next up is Michael.
I'm good. Hopefully, I can do this in 60 seconds. So, thank you everyone for attending, organizing, and sponsoring the BSD cons, be it Asia BSD Con in the spring, be it BSD Can. We had a completely new team, and I think, show of hands, did we do okay? Cool. And of course, EuroBSD Con, Philip busted his butt, and he has a great support team. And recently, a small ZFS event in Portland, and this event. So thank you, everyone who makes that happen. All those in the back who have just been quietly making it happen, thank you. Sponsors, thank you for continuing to sponsor. And my initial ask is, hey, please continue to do so. Pick an event that meets your needs, that fits your size, you name it. Now, my big ask. I really want to throw out our prospectuses. We've used the same rinse and repeat prospectus with the same tiers, the same features, a tote bag, a this, a that, a whatever. I want to see some creativity. And just in a few conversations this last 48 hours, people mentioned, well, at one event we had a capture the flag device in the badge, and that was our sponsorship, and it was great for getting engagement and all that. Please reach out to me or your favorite organizer with those ideas, because I do not want to see that same prospectus with a slightly higher number and just a slight revision. Any questions? Thanks again. 60 seconds?
Yeah, you're good. All right. Next up is Ross.
My name is Ross. I'm an independent developer. I don't write any compiled code. I'm probably the only one here. So my things are more like tips and tricks that I had to discover on my own that I didn't necessarily get tuned into. Extending RC. RC is RC. But it's very flexible in a lot of ways. Does what I call cascading configuration. This is one thing FreeBSD is really good at, is a system configuration that can be overridden by a user configuration, or vice versa. You know, so you can write code and put it in etcrc.conf.d instead of patching an RC script. And you can get a lot, you can add functions to an RC script that way. One problem is, and I mainly see this in ports, it doesn't seem like there's a standard for where rc.subber gets included. Sometimes it's included before things run, and sometimes it's included after. And that does make it problematic. It has to be included early. Let me make sure I have this right. So that anything that you put into rc.conf.d will be loaded as a... In other words, you can overload functions in the RC script, but only if it's included in the right order. SNDIO, no pulse audio. In a desktop system, SNDIO is an OpenBSD audio server with network capability. And it also has an option where you can make it capture the audio device or not. I don't know if I'm saying that exactly right, but I have an old HP laptop. The sound driver was incompatible with suspend resume. And I figured out that if I ran SNDIO instead of in network mode and in unprotected mode or protected mode, I can't remember which, I could unload the kernel module, shut down, bring it up, load the kernel module, and every piece of software was happy with SNDIO as the abstraction layer. On the no pulse audio side, I put a lot of work into figuring out all of the programs that I run that have a dependency on pulse audio, and 90% of them have a no pulse audio option. Sometimes that is an SNDIO option, sometimes it's not. But you can basically build your entire ports tree with a single makefile that eliminates pulse audio. Of course, you gotta be very proactive because it basically, I don't know how it does it, but it will creep in. And on my system, if I have pulse audio installed, it will crash when it goes to sleep. It's that simple. And so sometimes it ends up back on my system and I get a crash and I'm like, oh no, what's wrong? What's going on? And I have to remember to look, oh, there's pulse audio, get rid of that. But it is possible, I guess, is the message. How am I doing on time here? gmountver is a great tool. Mount verification lets you detach attachable storage without crashing the system. It just patiently waits. It suspends any I/O requests until it gets plugged back in. So you can unplug your, I like to run my system off of USB, but you can basically unplug it while your system's running, plug it into your phone, copy images over, pop it back in, and you've got easy file transfer that way. Reroute is a great feature. It's fairly new. It means you don't have to compile an MFS root into the kernel if you want to run from an MFS root file. So it overcomes the size barrier of MFS root. With reroute, you can basically just define the image on the file system or in memory that you want it to reroute from, and it will unmount all the file systems and basically start over from that point. So for like PXE booting and things like that, it can be very useful. And then my other tip is start with a minimal kernel. Just, it takes longer to load, but it's way easier to troubleshoot problems if you can unload anything while it's running. So that's it. Thanks.
All right, next up is Alan back again.
Hi, I got a tip and a trick for you. If your project A is hosted on GitHub, B is open source, and C runs runs on FreeBSD, then Cirrus CI is definitely the easiest way to set up continuous integration. And I swear, I'm not getting paid to say this. So here's my Hello World project. I started it 1 hour ago, and I'm going to show you how fast it is to set up CI. First off, you go to cirrusci.org and click on the Documentation tab. I've already put it up here. All you have to read through is this. That's it. And what it tells you is to install the GitHub application from the GitHub Marketplace. I have already installed that application, so my view is a little bit different than what you're going to see. Here's my personal GitHub settings page. In order to add Cirrus CI to a new repository, I scroll down, select repositories, and I find my new repository, Hello World. So, and I click Save. Okay, now I've enabled, there it is. You can see Cirrus CI is enabled for Hello World. So, I go back to my application and I need to write a CI definition. I've already copied one right here, but the part that you really need to pay attention to is this part. FreeBSD is a first-class citizen on Cirrus CI. No nested virtualization, no it's a type of Linux or anything. If you want to run Cirrus on FreeBSD, you just tell it which FreeBSD version you want. The rest of the file defines what we're going to do to test this application. It's a Rust application, so all we do is do cargo build and cargo test. Over here in my terminal, I do git add. Add the file. How am I doing on time, John? There we go. Yeah. So I added my CI Cirrus file, and now I push to the origin. We switch back to the web browser, refresh. And you see a yellow dot. My build there is queued on Cirrus waiting to run. Now, if I only have 2 minutes left, it might not start in those 2 minutes. We could sit here. Sure. We could wait here for a while, or we can just. All right, we'll just leave it here, and we'll let Gleb go.
Hi, I'm Gleb Smirnov, and I'm about to talk about stabilization weeks. Please raise your hands, those who know what I'm about to talk about. Not enough, not enough. So I suggested that exactly 1 year ago, and we started to implement this March, is that on the FreeBSD current, every last week of a month, we declare it stabilization week, which means that means two things. Please don't check in risky stuff. And ideally, don't check in anything rather than a bug fix or correction or documentation improvement or whatever. The second thing, you are encouraged to install this point, and we all who participate, we install the same point, and this helps a lot to stabilize it. Because we all run the same, nobody commits new stuff, we stabilize it. In the worst case, it takes a week. This is why it's called a week. It starts on Monday morning by GMT and ends on Friday. But I think we have it never lasted beyond Thursday, and usually it ends between Tuesday and Wednesday. So usually it is closed just by the fact that there are no reported regressions on this stabilization point compared to 1 month ago stabilization point. So so again, we started to do it in March. It means that we already had 8 cycles. Some of them were very simple. So my script declares the stabilization point. At Netflix, we do our own A/B testing, which is pretty large and extensive testing. but of course it covers only operation of our servers. So it utilizes only the drivers that we use, it utilizes only the protocols that we use and so on, but it's actually a very strong proof of that there are no regressions. I also update my desktop, I update my home router, there are other several people who also do that, and nobody reports regressions. On Tuesday, I say everything's all right, please continue your commits. This thing is going to scale. So I mean, the more people participate in that, the more value we will get from these stabilization points. So I'm encouraging everybody. So basically, 1 year ago, I encouraged everybody to consider that idea. Now that it's already running, I really encourage you to join it. At least start with your own personal desktop or laptop. Or if you're running a company, update your source base, your development branch, and you're not required to do it monthly. You can do it bi-monthly, because bi-monthly is divisible by month. You can do it 3 monthly, quarterly, you can do it annually, but participate as much as you can. Any questions?
So I know in the last year, Baptiste has stood up package-based builders that are building continuously. I wonder if it would be possible to, I don't know what the right way to describe it is. I would like a way to help with having people coordinate testing stab weeks. If we could get a package-based build for the start of every time with somehow with like a consistently tagged thing, so that people who want to opt into testing can easily package update, you know, and then whatever argument you need to add to say I want to test the most recent stab week. So I don't know if that's something Baptiste can help you with, but that might help make it easier, especially if we can give a canned recipe for people to know how to test the most recent one. That might be something that might help make it easier for more adoption. David, you want to say something? Yeah, take the mic.
What might be helpful is some command we can run on freefall, much like find the IRC channel password that says, what's the status? Are you in this window or out the window? If you're in the window, what is the hash or what's the base point? If you're outside, what was the previous one that's declared good? To remember where it is on a calendar, and if you're in the time zones across it, some way to dynamically, just real quick and easy, what's the status?
Yeah, right now it's automatic email that is sent. I guess I see what you mean. Okay, I'll shell out something.
Well, one thing we can do is, in terms of status, we could have like a simple generated page that gets it's like a table that gets a new line with a red or green for every week. That could grow over time, but we could have a get tag that slides forward to the last known good one. If we have a bad one, it doesn't slide forward to the next known good one. That's well, but okay, yeah, fair enough. Yeah, yeah, that makes sense.
Yeah, I got Git tags there on my personal GitHub. So back 1 year ago, when I suggested that, there was some pushback, like you are going to pollute our Git with your tags. So I said, as long as it goes experimental, the tags are in my repo. Just you need to connect a second remote. Yeah.
Okay. Thanks. All right. How are we doing on? I think we're still waiting for credits.
One of the disadvantages of Cirrus is that if you're using a free account, it can take a while for the job to start. But Warner needs a screen now, so you'll just have to take it on faith that my code compiles.
Yeah, we'll check again after. If it happens to come up, we'll check it. Let's finish.
Ladies and gentlemen, the great green check of fame.
Yeah, you can see cargo output. Click on the green check, click on details, view more details on Cirrus CI, and oh, that means I haven't paid money for this account. That's why it took a couple of minutes. And There we go. We can see the cargo test worked and didn't do anything. Because our-
Yeah, so the maximum time is by default 1 hour, but a max for free accounts on 2 hours, but paid accounts, you can do more if you're paying for the CPU? Okay. The answer is probably. Anyway. So in case you haven't heard my name is Werner Losch. I'm working on Linux boot, and now this time my screen isn't working. Yeah, there's a real possibility at any conference there'll be smoke or me hitting my laptop with a shoe or anything like that. Paul Henning stopped giving talks though, and I've stopped destroying laptops. I wonder if there's a correlation. Anyway, I wanted to give an update on Linux boot. Briefly, what this is Linux has the ability to replace the kernel with a new kernel. And a lot of minimal environments have gone to being, you have to use Linux boot to boot everything. And so there's a whole set of tooling for Linux, but it doesn't work with FreeBSD kernels because we have a lot of extra metadata for the kernel. How big is the memory system, what drivers are there, what modules are there, what tunables are there, all of this stuff is not preserved, or the Linux tools don't know about it. So I took our bootloader and made it a Linux binary. You can compile it as a Linux binary, it loads everything up, and then it calls the right calls, kexec load, which puts it all into memory, and then reboot with a special argument, which says, take that memory, copy it to the right place, and then jump to it. And then from there, weird things happen, and then our kernel starts, and we boot. And this works great on ARM64. I've run this on QEMU and 3 or 4 experimental systems that I think I'm still under NDA on, that are various flavors of Neoverse cores, and it works great. I've just started working on AMD 64. We get into the kernel, and the metadata isn't right, and we panic. Because I don't know why. I mean, if I knew why, I would have fixed it and be on to the next one. I don't know why. There's a couple of things, though, that aren't working. Right now, we assume PA equals VA for any callbacks into UEFI, and that's not strictly true. There's a virtual memory address or virtual memory mapping table that you need to get from EFI to set and make the call and then reset, kind of just like any other process. It has its own virtual memory. And I've been going round and round of Caustic because in my world, all of this works and is great. In his world, he's got too many laptops that lie. And he thinks there's more laptops that lie than are perfect servers, and he's probably right. So we're trying to figure that out. A couple of other minor problems. We support 4K pages on ARM64, but not 16K pages. That came on while I was doing this project, and Drew's asked me to do that. And there's also a couple of missing features. Right now there's no networking support, so you can't run the bootloader to load, to grab a kernel via HTTPS. And so the interesting thing that was in today's talks were the work at Juniper for the rescue kernel, the crash dump kernel. If you can have a crash dump kernel, then if we generalize it a little bit, then we can load our own kernels and do FreeBSD to FreeBSD kexec. And that's something I would love to do. It's not something I'll finish this year, but that's got a lot of interesting follow-on potential to the very useful rescue kernels that were talked about earlier today. So I thought I'd try to draw that together, that these can be quite related and quite useful for different features. So anyway, are there any questions that people have? We need to give him his own mic. No, here, hold on, here.
For those of us that have had our head in the sand, what are the platforms that only support a Linux boot? What environment are you forced into this?
So there's a number of ARM64 boards that different vendors have, that they have opted not to do the full EDK2 support. They just port the tiny bit of EDK2 that's specific to the board, and then they jump directly to the Linux kernel for all the other drivers. Yes, instead of having U-boot. Right, right. So they don't write the individual drivers for the different serial ports and video things, and I can't really get into the ones that I work on, but it's basically their deeply embedded custom boards or their evaluation hardware that boots Linux and has UEFI, but FreeBSD's bootloader doesn't work with that, but kboot works. So we just said, oh, we're not going to make them fix it. We're trying to do a quick eval. We'll just use the tool that we have that works. So I don't know. I imagine one of the things I hope to be able to do is to have this as a springboard for any cloud service that's Linux only. If they have the right support in the kernel, then you can boot the Linux kernel and then reboot into FreeBSD and everything is good. It's kind of what the hope is, but I have to get it like booting at all, so I didn't put my hopes and dreams on the slide. So, other questions, right here.
Thanks, interesting. So does it mean that after this is merged, whatever, I will be able to basically boot FreeBSD from grub or something, like basically use any Linux loader to boot FreeBSD kernel as well?
Not just any Linux, any Linux loader that supports kexec. So it's platform by platform. There's also PowerPC support for the old PS2, PS3. Sorry, I have a PS3. Reasons. Somebody gave it to me to make this work. Yeah, because I haven't been able to get it to work. I tried the CD that they said guaranteed would absolutely work, no problems, I'd have no hassle. It's been nothing but hassle. But it has not updated. It's the right firmware. I did check that. So yeah, so it's a significant hassle, and I think it's broken anyway, so I'm not going to worry about it. But you know, when the MD64 goes in, you'll be able to boot that if it uses a boot from UEFI. If it's a BIOS boot, I'm not going to support that, even though that's common in for things like core boot, because it's just a whole second path into the kernel that I have to get right, and I'm being significantly traumatized by the first path. So unless somebody has a compelling reason, I'm not going to do that.
Just a statement for David. All the like embedded Atom stuff does UEFI straight into Linux and then the kexec. So like all that embedded like file server stuff you can buy cheap, all of that stuff using Atom stuff, it's all like looks like embedded Linux. We're booting a cut down UEFI that doesn't boot FreeBSD. It only boots Linux. It doesn't have all the interfaces required. It's just enough to like suck a Linux kernel in off a particular flash storage chip and then just kicks it to start, and then it chain boots through kexec. Because why have two separate BSP teams when you can only have one BSP team that does all the drivers for Linux? That's what happens.
So the interesting use case I can think of, just related to what I was talking with Colin about, the challenges of doing CI for an operating system, which is you want to build a image and then you want to boot the image, and you don't want to do the thing we do today, which is to bit on nested virt or something crappy like that. Have you considered, if you have kexec, a CI pipeline where you build an image and then you kexec the new kernel to run your CI?
I have considered that. Also, I've considered, so right now it would have to be we build it on Linux, kexec FreeBSD and do the thing. But with the Juniper stuff, potentially we could do that. We would need to do, in order to do the kexec to do the testing though, we would need to be able to load the kernel in after we boot. And right now it's compiled in, and I've got some suggestions on how to make that better. But we could use that for the CI pipeline, because you don't have to have, it doesn't need to be a full general purpose kernel at that point. As long as it can run whatever's in the RAM disk, it's just whatever is in the RAM disk, and you're currently using it to grab a core. If there's no core, and it doesn't crash when there's no core, and we have a way of triggering it, because right now the way you trigger it is with a panic. There's a panic string we could set, reboot. but if you, yeah, if we, sorry, I'm just thinking out loud too much, but if we had something like that, it could be potentially very useful and interesting to do, and it could be done in a number of different ways. And if we're trying to do it, I'll absolutely support that, because I love that idea. Right, you just, well, yeah, and if your RAM disk is small enough, you just boot to the RAM disk that's in there. You load the kernel, you load the RAM disk, you jump to that, you have the RAM disk, you don't have to mount anything else, you run the test, and you're done. I don't know if I don't know how deeply you can nest the Russian nesting, the rescue kernels. Or you could just configure a swap partition and dump to that. I know, it's not the coolest, latest thing. Yeah. So, but we have options, I guess, is what I'm saying. Right, and we have to, we jump through a lot of hoops, and so it'd be nice if we can, deal with that, so. All right, thank you.
All right, so I didn't convince Alan to come up. On the Cirrus CI topic, we have a YAML file for the FreeBSD source tree that's checked in. I believe it defaults to not building things and using up all your credits if you do it in your own clone. But you have the option on a given branch that you can manually trigger builds of different combinations of compilers and versions, and it'll go off and do like a build kernel and so forth and tell you if it fails. Just using the little clicky web UI in GitHub. It's kind of nice. But you're coming. Is it? Hopefully we get slides. So in theory, well, it's thinking. Oh, I think that looks promising. That looks like FreeBSD. There we go. All right, well, Ed gets the last slides up. So that was the end of our whip talks. Sorry, it is late enough in the day that my brain is starting to slow. But that was the last session that we had for today. So Ed's got some slides he's bringing up for us. But thank you for coming to our fall summit this year. We've had a lot of fun over the past 2 days. I'm going to just start rambling over the slides that we have while they come up. So we have a lot of folks to thank. I want to give a big shout out to NetApp for hosting us and providing the venue space. That's a really big help in like AV support. Here we go. So we're coming. Is that what I'm supposed to do first? Oh no. All right. Okay. So first, before I get to thank yous, even though that's what I really love doing, we would like your feedback and input on your experience over the last 2 days, what you liked or didn't like or think could be better. So we have a little quick survey. You can see the link there. There's also a QR code. When we're actually done and winding down, we'll have the QR code up on the screen so you can find it as well. And we'll probably email this out to all of you and spam you that way too. Then, Oh, okay. We'll wait for all the phones to disappear. Yes, and we will have the QR code at the end of after we're all done. So, more chances to see all our pretty faces and listening to our, what was it, dulcet voices, I think is what we talked about earlier today. More chances to see each other. So we have several conferences coming up over the next year. We have Asia BSDCon back in Tokyo in March. Many of us will be back in Ottawa for BSDCon again this year. It's a little bit later in June, not quite Mother's Day this year. And EuroBSDCon was announced a couple, I guess 2 months ago. It's going to be in Croatia in September of 2025. And we will have some sort of fall summit in November-ish of next year as well. We just don't have a date or anything yet. All right, now on to the thank yous. So first, a big round of applause for NetApp for hosting us, providing space, AV support. It's been very, very helpful, letting us all actually use Wi-Fi and not complaining when we strung power cords up to tables when we probably shouldn't have. We also have the FreeBSD Foundation as a sponsor, providing all sorts of logistical support and planning and so forth, and helping with the catering. And then several other folks I would like to thank, if I can remember them. So first of all, we can't have an event like this if we don't have people who are actually talking. Otherwise, we'll just sit around and do nothing for 2 days. So thank you to our speakers for preparing talks and giving us lots of food for thought. Also, thank you to all the attendees, because as a speaker, it's not very much fun to talk to an empty room. You also get no questions if you have no attendees. So thank you all for participating, for all the group discussions in the hallway. I want to give a shout out to my live stream team who's helping out again this year. We had more fun with getting some mobile shots of people asking questions and so forth. So thank you guys. Thank you to Scale Engine. They donate the resources to allow our stream to get out of the building and out to YouTube and kind of deal with our fallback and recording and so forth. So thank you they donate that time and service. I skipped one. And lastly, there is a group of folks that all work together. We plan the Dev Summit in Canada every year and this event, and we meet just about every week with maybe 3 or 4 weeks off during the year. So we'll get about 3 weeks off and then we'll start planning for Canada. But I want to thank those folks. That includes several folks from the foundation, like Deb and Lauren and Ann and Ed. So thank you, and myself a little bit. Thank you to all those folks. All right, so one last reminder, please fill out the survey. Thank you all for coming, and we'll look forward to seeing you next year. So that's it. So give me a thumbs up when the stream is off. All right, so the stream is